online FDP on emerging trends in refrigeration and air conditioning, organized by Mechanical Engineering Department of Pimpri Chinchwad College of Engineering and Research in association with ISHRAE and Institute of Engineers, Pune chapter. We are glad that we have received a huge response from you guys, and we appreciate your time and efforts to join us in these sessions. Now, I request a respected principal sir, Dr. Harish Tiwari sir, to please give a welcome address.
Good morning, one and all. So, very good morning to all of you. First of all, I take this opportunity to welcome you all for this very relevant session that is on refrigeration and air conditioning, recent trends in refrigeration and air conditioning, as the application of refrigeration and air conditioning, and the relevant fields. So, I take this opportunity first of all to congratulate the Department of Mechanical Engineering, Chinchwad College of Engineering and Research, and the coordinators, in particular Professor Vijay Desai and his team, for taking this initiative and arrange this workshop. I take this opportunity to thank ISHRAE, that is Indian Society of Refrigeration and Air Conditioning, as well as IST for joining hands with us, and the full team who are there to make this workshop successful. When I say successful, because there are more than 1,300 participants at the national level. We thought of to arrange a workshop at the college level, inter-college level, at the university level, but when we started getting the response, then we are getting the response from all parts of Maharashtra, from some parts of other parts of we can say country also, and hence the workshop we can say that it's a national workshop that is on emerging trends in refrigeration and air conditioning. I was going through the you can say some information that I'm getting in this lockdown period, and there are other workshops also. So it's a good initiative. We teaching faculty have responded very nicely to you can say utilize the lockdown period for our own development, because our own development is when we are acquiring more and more knowledge, when we are enriching our knowledge, it is ultimately going to be passed on to the students, and that is what actually going to matter. When we see the syllabus of refrigeration and air conditioning, then quite often I always think that there should be something that is, you can say, called application of refrigeration and air conditioning, and then design of refrigeration and air conditioning. That is something missing from our UG workshop. Yes, definitely it is taken care at the college level when we say something that is beyond syllabus we are teaching. But yes, at the university level also, we can recommend this so that it can be included as a part of syllabus only. So that will be a good thing. Then when we talk about the refrigeration and air conditioning, then refrigeration and air conditioning is one of the fastest growing industry. Yes, when we compare the energy consumption, total overall energy consumption, then in that energy consumption, especially when we talk about the developed countries, more than 40 to 50% the power consumption of the energy consumption is for the refrigeration and air conditioning. Big systems, centralized air conditioning systems, air conditioning everywhere you can say has become a part of the routine life in developed countries. When we talk about the developing countries, slowly it is picking up, But in countries like India in particular, when we talk about, they are very rapidly growing from a developed country to a developing country to a developed country. Then we can observe the trend of consumption of energy in the last 10 to 15 years. A huge amount of energy is being consumed. In particular, when we talk about the multinational companies, the centralized air conditioned buildings, if you consider their overall energy consumption, a huge amount of energy is consumed to take care of the air conditioning part. In other parts also, for example, you can consider the example of automobile. Just around 15 to 20 years back, air conditioned car were considered to be luxury. Now, even the smallest of the car, like you can consider the example of Nano, you can take the example of Alto. They are also coming with air conditioning systems, and that is the inbuilt air conditioning system, and it has become very common. Yes, in the other in parts where the, you can say, where the climate is not that warm, there also people are nowadays using refrigeration and air conditioning. When we talk about refrigeration and air conditioning, then it is to be talked in totality. It is not something like that, just controlling the temperature, but it is control of the environment. It is, you all know, because you all are from mechanical engineering, that too from the refrigeration and air conditioning background. But when we consider the technology, refrigeration and air conditioning, officially, it first time it was introduced in the, you can say, year 1902 by Carrier, when he presented his work for the first time. That is considered to be officially for the first time. People come to know about refrigeration and air conditioning, but refrigeration and air conditioning, in particular air conditioning, or refrigeration also, is a, you can say, old technology, known technology. Only the methods, scientific methods were introduced. For example, you can take the example of evaporative cooling. Evaporative cooling is very, very common in countries like India, where the environment is, where the atmospheric means the overall humidity in the environment is on the lower side. That time, evaporative refrigeration is very, very relevant for cooling water. In particular, we are using pots, so that is also nothing but application of refrigeration. So it is a old technology. But if you consider the scientific, that is the first technology 1902, it was introduced. From that time, almost 120 years, only mainly two types of systems are used. These two systems are nothing but, you can say, heat generated cooling, where absorption refrigeration cycle is very common. Yes, and the second is nothing but the vapor compression refrigeration system. When vapor compression refrigeration system was introduced for the first time, then almost in most of the cases it has taken place of the heat generated cooling, and almost everywhere in every application vapor compression refrigeration systems are used. And more or less the technique, the basic technique, that is the basic components, the core components remains the same. Not much has been done to change the basic refrigeration system. Yes, because we believe that it is a very, very efficient system, because when we measure the coefficient of performance, the coefficient of performance in the vapor compression refrigeration system is more than, say, 3. Sometimes even theoretically when we calculate, it is more than 5 also. That is, for when we spend 1 unit, then we are being able to transfer at least 3 to 4 units of the, you can say, the heat. That is what is nothing but coefficient of performance. So that is, we believe that, because when we deal in terms of efficiency, the efficiency in the best of the best engine is not more than even 40%. But the coefficient of performance is very high, and that's why it is supposed to be one of the very, very, you can say, popular system. That, and simple also. If you consider the simple, you know, the refrigerators are working for more than 20 years without any single, you can say, maintenance problem. So it is a very, very reliable technique also. But then there were some problems in 2 decades back about the use of the refrigerant. The use of refrigerant, it was you can say, known that the refrigerant that we are using, they are responsible for the global warming and the ozone depletion layer. That time, some new refrigerants were suggested. The old refrigerants, which were discarded like ammonia, they are again now introduced. So there is a scope in the field of use of refrigerants. You should, yes, one should look for the natural refrigerants. What are the options available? So all these things are there, the relevant areas are there. But dear friends, think of something that is related to, you can say, heat generated cooling also. Because in countries like India, where there is huge amount of solar energy is available, low grade energy, waste energy is also available. So can we think of something where we can power our system by using the low grade energy or the waste energy? And that can be an ultimate solution for the, you can say, countries like developing countries, because we have to spend a huge amount on the energy sector. So that can be one of the areas where we can work. There can be many other areas also. We are available with a very good panel of speakers. All these people will be speaking about the different, you can say, different aspects of refrigeration and air conditioning. So once again, I congratulate you all to make it a point to take part in this workshop. Yes, taking part in this particular workshop, definitely, I think that this workshop is going to be very, very fruitful. All of you are going to enjoy this workshop and enrich your knowledge. So I congratulate you all. I welcome you all for this 6-7 days and this workshop. I wish all the success for this workshop. I thank the organizers. I also thank the you can say head of the department mechanical for taking this initiative. Thank you very much. Thanks a lot.
So thank you, sir, for your words. So without wasting much time, let us start with the first session. The topic for the session is requirement and expectation from HVAC systems. To talk on this topic, we have Dr. Udaras sir, who is assistant professor at IIT Bhilai. Dr. Udaras sir has completed his MTech from NIT Calicut. He has completed his PhD from IIT Delhi and postdoc from Hong Kong. Udaras sir has about 21 research papers published in international reputed journals. Now, I request Udaras sir to please take over the session. So you can unmute and you can start with the session.
Yeah. So, am I audible now? Am I audible now?
So I think you are not audible.
Hello.
Hello.
Hello. Hello.
So I think you are not audible. Can just hello.
Okay, so I will do one thing. I will just disconnect it and then connect again.
I think we have a problem right now. Sir will join in a second.
Hello. Hello.
Hello.
Hello. Hello.
Hello. Hello. Yes, sir. You can share your you can share your screen and you can start with the presentation.
Okay. Is it visible now? Hello? 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 Okay. And what about the presentation? Is it visible? Okay. Then I will start. Okay. Hello. So good morning, everyone. So I'm Dr. Udayraj from Department of Mechanical Engineering, IIT Bhilai. So today's topic, as you know, that this is the FDP related to refrigeration and air conditioning. So I thought it's better to talk about the requirement and the expectation which we have from HVAC systems specifically, and what are the other alternative options which are more energy efficient and which are more promising, which are coming into the domain right now. Okay, so with this, we'll start this. So, as you know, that we are talking about the expectation, right? So, in throughout this presentation, we will be discussing about the. We will be basically answering. We'll be trying to answer basically these three questions, like why we need HVAC systems, okay, and why, as the previous speaker told you, that means this is not a new technology which is there in the market, right? It's very old technology. Uh, this refrigeration and air conditioning, we are talking about it since very long. So why we are still interested in discussing it? So that also we'll see, and and then we will also discuss about the challenges associated with it. Okay, what are the challenges which we are facing in the HVAC systems? And then what are the solutions or the research direction uh, in which people are working, and what are the scopes in this particular domain? Okay, so first we will talk about few basic terminologies, and then we will gradually move ahead. Okay, so the first, one of the first terminology related to HVAC system, when we talk about it, is the indoor environment quality. So now, uh, why the, as the name itself suggests, indoor environment quality. So basically, it tells you about the quality of the indoor environment. Okay. So now, why the indoor environment is important? So as we can see that means most of us spend most of our time indoor. Okay, so either we are at our home, or say, for example, institute or schools, colleges, malls, or means, so it has been found that we spend most of our time indoor. Okay, so the quality of indoor environment is very important because it affects health as well as comfort of the occupants. So it basically incorporate various aspects. So like when we talk about indoor environment, so basically we talk about indoor air, we talk about the thermal quality inside the domain, and then we also talk about lighting quality, then sound quality, odor quality. So when we combine all of them, so basically this governs our indoor environment quality, and which ultimately affects our health or comfort. And all of these aspects are actually very important. So, and there is expectation as far as the occupants are concerned. So there are expectations related to each and every one of them, right? And as far as the HVAC system is concerned, so it can basically help us in meeting the requirement related to indoor air quality as well as indoor thermal quality. So these two aspects are very important as far as the HVAC system or HVAC systems are concerned. Now, this is just another view. So basically, it says it talks about heat waves and its mitigation, right? So now, in the recent time, we have seen a lot of heat waves. So heat waves is not related to directly related to indoor environment or HVAC system as such, but at the end of the day, it affects the whatever is the outdoor environment. It basically affects your indoor environment. So, like cooling load, heating load, and all these things, right? So basically, outdoor environments also affects the indoor environment. So we'll talk about it later. And then the second aspect, when we talk about indoor environment quality, is the thermal comfort. So thermal comfort is nothing but it's a state of mind which basically expresses satisfaction with the thermal environment. So basically, it talks about the how warm or cold we feel, okay, in relation to our indoor environment or the environment which we occupy. So, so basically, one of the major objective apart from air quality is to maintain thermal comfort as far as the HVAC system is concerned. So, so we should know what is thermal comfort. So, in that aspect, so it has been defined that if these four conditions are met, like whole body thermal comfort, means whole body thermal equilibrium, mean skin temperature. So basically, these four are the criteria which defines thermal comfort of human. Okay, so when your body is in thermal equilibrium with the surroundings, then this is one of the indication that you are in a state of thermal comfort. When we means what is this thermal equilibrium? Basically, you know that your body produces heat continuously in the form of metabolic heat generation, right? And and since it is producing heat and it is also exchanging heat with the environment, okay, whether from body to the environment or from environment to the body. So if that equilibrium is maintained, like whatever heat is being produced, it's being dissipated to the environment, then we say that we are in the thermal equilibrium with the surrounding. So under such circumstances, your skin temperature should be within the comfort limit 32 to 34 degrees Celsius, and body setting should be within the comfort limit, and there should not be any local discomfort at any body part. So basically, these are the four indicators which can be used to identify whether a person is feeling thermally comfortable or not. Okay, and thermal comfort is also important as far as the HVAC system is concerned. So thermal comfort is also important in the workspace or in the office because it defines the level of satisfaction and work efficiency. So this table is showing basically the telegraph key operator study conducted by NASA. So here you can see that as the ambient temperature is increasing, the number of mistake which these telegraph key operators are committing are also increasing. So, so it is it shows that it is very important to maintain a suitable ambient temperature. Okay, so and HVAC system helps us in maintaining it. So later we will see that it's not only the temperature, there are other factors also which affects thermal comfort. Okay. Now, what is human heat balance? So basically, you can see here that our human body is producing metabolic heat, and then it is exchanging heat with the surrounding by radiation, convection, conduction, and then we have a special mechanism of sweating and perspiration. Okay, so we lose latent heat out of it, and then also respiration. Okay, so there also we have sensible as well as latent heat exchange. Okay, so this basically defines the heat balance, where this S is nothing but the heat stored in the body. So when the when heat stored in the body is zero, it means your body is in thermal equilibrium with the surrounding. And these heat exchanges with the surrounding, between body and the surrounding, can be uh, in both the directions, like from either from body to the environment or from environment to the body. Depends on the outdoor environmental temperature or conditions. Like say for example, in the first case, you can see that it's a case of a cold environment where the human is surrounded by a cold environment, relatively cold environment. So basically, he's losing heat by conduction, convection, and radiation, and obviously perspiration. So in the second case, you can see that heat is being basically transferring from environment to the body by three mode of heat transfer: conduction, convection, and radiation. Right? And perspiration is always out of the body because you are sweating, which is taking away latent heat from your body. So depending upon whether your body is losing heat or gain, okay, your body temperature increases. Means whether this S value or the heat stored value is positive or negative, depending upon that, your body temperature increases or decreases. Okay. Under normal circumstances, you can see here that the body temperature should be approximately 37 degrees Celsius, or the body core temperature to be precise. So here, so to maintain that 37 degrees Celsius indoor environment, or sorry, body core temperature, so there is a very intelligent mechanism which we have in our body, which is called the human regulation, human thermal regulation. Okay, so this system exists in our body, which tries to maintain our inner core temperature around 37 degrees Celsius. Okay, so this 37 is a general value. So generally it varies within a narrow range of say 36.5 to 37 or 37.5. So there is a very narrow range in which we need to maintain our body, and you can assume that we can survive, uh, if not easily, then at least we can survive, say from 0 degrees Celsius to 50 degrees Celsius, right? Outdoor environment. But in throughout this range from 0 to 50, our body core temperature should be within this very narrow range, 36.5 to 37, right? So this is to maintain this, or to basically absorb a wide range of environmental temperature or environmental conditions, and to maintain our body core temperature within a narrow range of 37, around 37. So we have a very intelligent system which exists in our body, which is called the human thermal regulation system. Okay, so what it does, so basically, if you see the cold environment, so we have a few mechanisms in our body which basically help us to maintain our core temperature with around 37 when we are exposed to cold environment. So these mechanisms are vasoconstriction, right? And then you can see such kind of goosebump, which you can see, or which you can feel when we are exposed to cold environment. And obviously, the third mechanism, which is very strong mechanism, which we have to maintain the core body temperature when we are exposed to cold environment, is the shivering. Okay, so this you may have experienced it, that we shiver, right, when we are exposed to cold environment. So basically, when all these mechanisms like vasoconstriction and this goosebump fails, so we have a very strong backup of shivering mechanism, which can generate a large amount of heat and can maintain the body heat balance. And as far as the hot environment is concerned, so when we are exposed to hot environment, say 45 degrees Celsius or so, and in that case also we need to maintain our core temperature around 37, right? So it means we need to extract or dissipate as much heat as possible from our body to maintain it around 37. But since the temperature gradient is negative, so basically heat will transfer from outside environment to the body, right? So to tackle these things, so we have two mechanisms uh, as a part of thermal regulation system. One is the vasodilation, where our arteries and veins dilate basically, and the blood flow rate increases. And then the second, which is a very strong mechanism which we have, is the sweating. Okay, now you know that when we sweat, we dissipate latent heat. Okay, and this latent heat is very strong, like significant as compared to uh, sensible heat. So we can dissipate a large amount of heat. In fact, when the outdoor temperature is higher than 37 degrees Celsius or say 38, 39, so the only effective mechanism by which we can dissipate the heat generated inside our body is the sweating. So that is why it is basically suggested to drink as much as water as possible during summer. Okay, and this is again the same diagram which is showing you the vasoconstriction and vasodilation. So basically, all these mechanisms helps us in maintaining the core temperature within the range of 36.5 to 37.5. Okay. So if core temperature goes beyond this range, like say if it is goes below 35 degrees Celsius or above 39 or 40 degrees Celsius, there are high chances that people may die. Okay, and to maintain it and or to activate all these vasoconstrictions, shivering, okay, and sweating. So we have a CPU in our mind. Okay, so in the brain there is a hypothalamus which basically activates all these mechanisms by receiving sense signals. Okay, and how these signals are received. So for that we have receptors in our body. Okay, receptors or nerve ending in our body. Okay, so these are basically scattered throughout the body. So when you see this is a basic structure of a skin, right? So you can see that you have hairs here, and then you have epidermis layer, then you have dermis layer, and then you have subcutaneous layer. So in these skin layers, there are various receptors or nerve endings which we have. So which you can see from this right hand side figure. So I don't know whether it is visible properly or not, but you can see here that there are various kind of receptors. Like this is a Merkel disc, then you have Ruffini ending, then you have nociceptors, then you have thermoreceptors. Okay, so you have large number of mechanoreceptors as well as thermoreceptors, right? So and these different kind of receptors have different functions. Okay, so what happens is like all these receptors which we have in our body, so they sense, like say for example, these thermoreceptors which we have in our body, they sense the warmth or cold. Like suppose if you are exposed to a cold environment, okay, so you feel basically cold. So how you feel it? Because uh, by sensing the temperature with the help of these thermoreceptors, okay, so which are distributed throughout your body. So when we want to categorize it based on the functionality, sorry. So in that case, these thermoreceptors basically sense heat, I mean temperature, or you can say warmth or cold. And then these Merkel receptors basically they sense the pressure. So say if I'm touching my body, okay, so I can feel some pressure, right? I can feel that someone has touched my skin on my body. So this is basically sensed by these mechanoreceptors, Merkel discs. Okay. So whatever pressure you apply over your skin, these are basically sensed by these receptors. So as you can see that these receptors are basically at the top, okay, near the epidermis layer. So whatever small pressure you apply at your skin or at your body, so you can feel it because of the sensing capability of these receptors, these Merkel disc. Similarly, these Ruffini endings, so basically they sense the scratch, okay, stretch of the skin, and it also governs the finger movement. Then you have these Anisian corpus. So these are basically vibration and these sense vibrations and pressure. And then you have these Messner receptors. So basically these are these receptors sense tactile and light touch. Okay. So in this particular, so right now we are only basically more interested in the thermoreceptors. Why? Because we are talking in terms of thermal comfort. So basically, you can see here that you have some thermoreceptors which are distributed here. Okay, so basically these can sense temperature and then it sends a signal to the. So after receiving those signals, like whether temperature is higher or lower, they send a signal to your hypothalamus. Okay, that okay. So now right now the body or human body is sensing a cold. So they will send a signal to hypothalamus, which is situated in your brain, and then it activates like if it is a cold environment or if the skin is or the sensors are feeling cold. So what will happen? This hypothalamus will basically uh, do any one of the three mechanism or maybe simultaneously all the three mechanisms. It depends on the intensity of signal. So this hypothalamus sends a signal and it sends a command to the for the vasoconstriction, or it may send command for shivering also, or it may send command for this hair to become straight also. Okay. I hope this is clear. And these thermoreceptors are basically these receptor basically activates at depending upon the temperature range. So there are warmth receptor, there are hot pain receptors which activates at a higher temperature, and you have cold receptor and cold pain receptor. So if you see, if your body is exposed, or say if I am touching a very hot object uh, uh, on your body, so okay, so what will happen? Say if the temperature is around 50 degrees Celsius. Okay, if a hot object which is maintained at 50 degrees Celsius, I am touching at your body. So you will not feel hot or cold. Basically, you will feel a pain. Okay, so why? Because at 50 degrees Celsius, only these hot pain receptors become activated. So they activate. Okay, so you will, instead of feeling warmth and cold, you will feel hot pain. Similarly, when you are exposed to a very cold environment, say for example, if you are touching your finger with a ice cube or say for example ice, so you will not feel cold after some times. You will feel cold pain actually. Okay, why? Because the temperature there is lower than 5 degrees Celsius or so. So at that particular temperature range, only the cold pain receptors is activated. Okay, so that is why instead of feeling cold, you feel pain when you touch ice. Okay, so with this background, I think we know like how the signal is sensed, and then it sends a signal to hypothalamus, and then accordingly the thermal regulation system activates, right? So, so which tries to maintain thermal comfort. Okay. So here you can see that, and as we are talking about the thermoreceptors, and I told you that the density of these receptors is different at different locations. Say for example, when you are going outside in a very cold environment, you protect your nose, right? Or you protect your fingers first. Means you wear either gloves, and then if you have noticed, you feel cold, means more cold on around your extremities, right? Like nose, uh, ear, fingertips, and all. Why? Because the number of cold receptors at these locations are more compared to any other location. Okay, so that is why we feel more cold on these locations, at these locations. Okay, so similarly, when we talk about warm receptors, so their intensity is also different. Say, for example, the density of these warm receptor is higher around means in this particular area around your face, like head, chest, and all. So this you can see from this particular figure, where this is a basically human trial study which is conducted. So sorry. So you can see here that when the body is exposed to a hot environment, see, I hope you are able to see my cursor. So if you see this last column, so when body is exposed to hot environment, so you can see that the people are feeling more hotter in these two sections, head and face. Why? Because the number of warmth receptor or hot receptors are more there. Similarly, when the body is exposed to a cold environment or human is exposed to a cold environment, you can see that they are feeling more cold in at foot, hand, and arms. Why? Because the number of or the density of cold receptor at these locations is higher. Okay, so and it can be seen that these local thermal sensation, which we sense with the help of thermoreceptors, basically they govern the thermal comfort. Okay, they govern the overall thermal comfort. So if you see in this cold environment, the uh, the cold which is basically sensed by the body or by the human being at these locations is around minus 3.1. So this basically is governing the overall sensation. Similarly, these local thermal sensation, warm sensation or hot sensation at head and face is basically governing the overall sensation. Okay. And these sensation, basically these number of receptors or the thermal sensation for a given environment, it depends on a lot of factors. It depends on the age. Okay, it depends on the sex. It depends on means all other factors, including the acclimatization also. Okay, and the location where you are. So in this, you can see that this is another study which shows that female are more susceptible to cold rather than hot, and they have a wide range of variation in the cold environment compared to hot environment. So in general, overall, humans are more human can survive in a hotter environment better compared to cold environment because the number of cold receptors are more compared to hot receptors, and also the number of cold receptors are located means towards the outer side of the body, towards the exposed side, whereas the warm receptors are located deeper inside compared to cold receptors. So, as far as the research is concerned, so this is one of the active area in which people are currently doing research. So, so there are few some of the areas I have listed it out where the active research is going on, and there is a lot of thing which needs to be done in one of these areas, specifically for Indian context, because in India, I have not seen any study which people have done like this. Okay, so there is a huge gap which exists. So what people try to do uh, in this is why it is important to understand all these things is because ultimately this is governing your thermal comfort, and why you are using HVAC systems. You are using all these HVAC systems basically to obtain the thermal comfort. Okay, so in order to have a very energy efficient system, or in order to utilize a system, forget about it whether it is efficient or not. In order to utilize it effectively, you need to understand how the thermal comfort is governed. because at the end of the day, the overall objective of using HVAC system is to achieve thermal comfort. So in that, considering this, it is very important to understand how thermal comfort is basically governed. Okay, so it depends on, so this thermal comfort is basically people are trying to understand it, the sensory differences which exist between among various people, okay, as a function of age, gender, and location. Why it is important? Because if you want to have a HVAC system in an environment, say for example, in a mall, right? If you want to design it now, in a mall, you may have people of all age group, right, of different genders, right? So a person of say at of 30 year of age may feel comfortable, but a person with, when say for example 60 year of age may not feel comfortable, right? So now how how their comfort is different, like how their sensory behavior or their thermal sensation is different. It is important to understand, because then only you will be able to design a system which can cater both, or at least cater 80% or 90% of the population, which is basically the benchmark. And again, how this local thermal sensation governs the overall thermal sensation. This is also one of the areas where people are actively working currently. Okay, and depending upon that, say for example, if I'm cooling my head, okay, and I'm cooling my arm, right? So now, which location I should cool so that I can feel more comfortable, right? So this is called the local cooling, which we will be discussing later. Sorry. So till now we talked about temperature only when we were talking about thermal comfort. But this thermal comfort is basically governed by all these 6 factors. Okay, these two are classified as, means these can be classified as either personal factors or environmental factors. Now, when we talk about environmental factors, so we have 4 environmental parameters, or which govern basically the thermal comfort or which affect thermal comfort, like your humidity, right? Environmental humidity, and temperature of the surrounding air, then the mean radiant temperature, then the airspeed, the speed of the wind or air surrounding you. So these are the basically environmental factors. These 4 are the environmental factors. And then you have these personal factors also, like what clothing you are wearing. Okay, this is your personal choice. And also the metabolic rate. So what kind of activity you are involved in. Okay, so now as far as the HVAC system is concerned, so basically these systems are used to maintain or to alter these conditions like humidity, air speed, or air temperature. So basically these 3 factors can be governed, means, and this radiant temperature also sometimes indirectly you can say uh, uh, can be governed or can be altered with the help of HVAC system. But major thing is to control humidity, air temperature, and sometimes air speed also. So these 3 are the important factor as far as the HVAC system is concerned. And then these are personal factors like what clothing you are wearing and the metabolic rate. And depending upon your activity level, this metabolic rate is higher. Basically, if you move from here to here, so your metabolic rate is increasing. Okay, and in a same space, one people may feel comfortable, whereas other may not feel comfortable. Basically, why? Say for example, in this particular case, this guy is feeling cold and this guy is feeling warm or hot, right? Why? Because in as the air is going towards this direction, its temperature is increasing. So basically, you can see air temperature is increasing. So it plays a role. Also, there is not enough circulation around this particular guy. So it means that there is less amount of the amount or the air velocity or the speed of air around this guy is lower. So these two are the governing factor in this particular case, resulting in a situation that this guy is not feeling comfortable. Okay. Whereas if you see these two guys, there is sufficient amount of air circulation, and also uh, there is a contact with relatively cooler air. Okay, so resulting them means this guy is feeling cold and this guy is feeling cold. So you may note down your questions, so we can address them at the end. Now, thermal comfort is also governed by the clothing which you are wearing. Say this is your psychometric chart, you all of you know. So here you have a relative humidity, right? And here you have a temperature. So in this case, it is operative temperature, which is basically taking into account the air temperature or the dry air temperature, and also the mean radiant temperature. So, and this glow is the unit of insulation in case of clothing. So, one glow means you are wearing a clothing of higher insulation, and 0.5 glow is the clothing which you are means of lower thermal resistance. So, basically, this you can say this is one glow means your normal office wear, and this zero point 0.5 is your summer wear. So, as you can see, this clothing also governs your comfort limits. Okay, so when you are wearing, so basically these shaded areas are showing you the environmental condition at which you will feel at which you will feel comfortable. So now, when you are wearing a clothing with higher insulation, okay, say one glow, so you will feel comfortable at a lower temperature. Why? Because your clothing itself is acting as a thermal insulation, right? So, and when you remove the clothing, say you are removing a jacket and you are wearing a kind of summer wear, so you will feel more comfortable at higher operating temperature. Okay. So what I'm trying to say is that it's not very straightforward. Like, say, there is a general notion that people feel comfortable when the environmental temperature is 25 degrees Celsius and humidity is 50%. Right. So this notion is actually not correct. So it's not that simple, uh, right? There are only two parameters in it: 25-degree air temperature and 50% humidity. So there are only we are talking only about two parameters. Whereas the thermal comfort, it depends on all the six parameters together. Okay, so we need to see the problem in totality. Say if I'm wearing woolen clothes, okay, and I'm maintaining 25 degrees Celsius and 50% humidity, I will not feel comfortable, right? Because my clothing insulation is also governing the thermal comfort. Okay, so all these factors together affect thermal comfort. So we need to take care of all of this. And similarly, a person who is sitting and doing some kind of office work may feel comfortable at 25 degrees Celsius and 50% humidity, but a person who is doing exercise in a gym may not feel comfortable at 25 and 50% humidity. Why? Because in that case, the metabolic rate has changed. So basically, it will significantly alter your human heat balance, right? The storage term which we talked about earlier. So we need to see all of them together. And yeah, so there is a parameter called PMV, okay, predicted mean vote. So depending upon these value of these six factors in totality, these six factor totality govern the thermal comfort, or we can say predicted mean vote. Predicted mean vote is basically nothing but it is a value which is ranging from say -3 to +3. Okay, and PMV value 0 indicates that you are feeling neutral. Okay, means or comfortable. And as the PMV value is increasing, say +1, +2, +3, you are going from means neutral to warm and then hot. And similarly, this side also, you are feeling cooler and cold. Okay, a -1 to 3. So it has been found. Uh, yeah. So as we were talking earlier, so when we install a HVAC system, okay, say for example in a classroom, so there are 50 students, so all of their their there may be a difference related to gender. Okay, there may be differences related to age, and obviously everyone is different, even if their age is same or their gender is same. So their thermal sensation is different because they may have some are more sensitive towards hot environment, or someone is more sensitive toward cold environment, depending upon how many thermoreceptors they have. Okay, what is their density and all those factors. Now, so in a room of 50, not all of them will not feel the same level of thermal comfort. So some few people may feel neutral, few may feel slightly warm, few may feel cold also. Okay, so they have basically different sensation. Okay, so it is impossible for a HVAC engineer to satisfy all of them. Okay, but if we are able to satisfy 80% or 90% of them, that's fine. Okay, so we are always bothered about 80% or 90% satisfaction. Okay, so if 90% of the people or 80% of the people in a room are feeling neutral, or say slightly warm or slightly cool, okay, then it's your whatever you have installed is good enough. Okay, so so there is another term called PPD, which is basically indicating the number of or the percentage of people dissatisfied. So this there is a graph here at the end which shows on the x-axis you have PMV, predicted mean vote, and on the y-axis you have PPD, number of people dissatisfied, who are not satisfied. Okay, so if you see here, so 0 means neutral. Okay, 0 PMV means neutral. So if you see here, 10% of the people are dissatisfied, and this PMV ranges from 0.5 to 5, minus 0.5 to 0.5. Okay, so it indicates that if you want to maintain 90% of your satisfaction level in a room, as far as the thermal comfort is concerned, then you need to have a predicted mean vote within this range, minus 0.5 to plus 0.5. So which is around this, right? Means around the neutral, like between slightly warm and slightly cool. Okay, and towards the neutral, close to neutral. And depending upon all these environmental factors which we talked about, like relative humidity, air speed, and metabolic rate, okay, and obviously the clothing insulation. So it may vary. Your comfort requirement or your comfort may vary. So these are the studies which are conducted in 3 airport terminals of London and Manchester. Okay, so it has been, you can see here that, so what they did human trials, or you can say they did the field trials. So they asked people how they are feeling on a -3 to 3 scale of thermal sensation. Okay, this is ISHRAE scale. And they asked like how they are feeling, means comfortable or not. And then they found out how many percentage of people are feeling thermal sensation in this 0.10 or 1. So you can see here that for a satisfaction of 90% of the people, this thermal sensation lies -1 to 1. Okay, instead of 0.5 to minus 0.5 to 5, which we are talking about. Okay, so under such circumstances, we can say that if your predicted mean vote is between -1 to 1, means that's good enough. Like if that's the case, means it can be done, because anyway 0.5 to 5 is too theoretical. And you can see here that person, say for example, I will just explain one graph only because we have limited time. So if you see here, say for example, this graph, last one, it shows PMV versus metabolic rate. So in the x-axis, this metabolic rate is increasing, and y-axis PMV, right? So now PMV is 0 when the metabolic rate is 70. Okay, so it means the person was feeling comfortable at 23 degrees Celsius. But if under same circumstances or environmental condition, which is 23 degrees Celsius, if you increase the metabolic heat or metabolic heat rate generation from 70 to 130, it means now a person is physically active. Okay, so if you increase this metabolic rate, you can see that his PMV is going above what? The same environmental condition. So this shows that a person, if I consider -1 to 1 PMV as a comfort limit, so this person is at 23 degrees Celsius environmental condition. This guy was feeling comfortable between 70 to, say, for example, 120 metabolic heat generation. Okay. Similarly, you can see effect of other factors also. Now, so till now we have seen that. Till now we have seen that this thermal comfort, in order to obtain thermal comfort and air quality, right? So we need to have HVAC system, right? These are two primary function of any HVAC system. Okay, and there are other concerns also, like how the thermal comfort affects the economy or economics, right? So there are studies in the literature which shows that as the PMV increases beyond zero point 0.5 degrees Celsius, so considering that our thermal comfort limit or the range is minus 0.5 to 0.5, so if you can see that if it is crossing this range, so you are experiencing a huge productivity loss. Okay, so that is why it is very important to maintain uh, the environment in which inside your office or factories, right? At a in such a way that people, most of the people feel comfortable, say 80 to 90%. So based on this study, you can see here that there is a uh, because of the productivity loss, when you maintain a temperature 2 degrees Celsius higher than the neutral temperature. Okay, so you will have a huge productivity loss, which will be basically equivalent to 2.5 to 5 times the cost of the HVAC system over its life cycle. So basically, it says that as far as the, if you compare your productivity loss due to productivity, okay, economic loss due to reduced productivity, and if you compare your cost of your HVAC system, so the loss is 5 times higher than the cost of HVAC system. Okay, so it says that it's better to install HVAC system, okay, rather than losing your production. And the second factor is the indoor environment, indoor air quality. So now, so there are studies available in the literature which says that uh, where it has been found, even WHO also says it, that the indoor pollutant level is sometimes or many times higher than the outdoor pollution level. Okay, because inside environment we have lot of factors, like obviously outdoor in air pollution anyway come inside, right? So but there are additionally there are other pollutant source which exist in your house or various locations, right? Even the paints which you use, they emit volatile organic compounds and all. So basically, it can be 2 to 5 times higher than the level of pollution which exists outdoor. Okay, and considering the fact that we spend 80 to 90% of our time indoor, it's very important to have a very good indoor air quality, or it's very important to have low level of pollutants inside. Okay, or in general, it's important to have a very good indoor environment. Okay, so how to reduce the level of pollutant which exists inside or indoor? Okay, so there are there can be two possibilities to do it. One is you basically reduce the source. Okay, if say for example, you should avoid using paints which emits VOCs. Okay, you should avoid smoking inside, and there are number of cases or number of factors. Okay, so that way you can control pollution at the source. Okay, and then there is another method which is to have a proper ventilation. Okay, now this ventilation may come naturally. You can use natural potential which exists in the environment, like, okay, and you can also use mechanical systems like HVAC systems, as we use in HVACs. Okay, to have a proper ventilation so that you can reduce the indoor pollution level. Okay, so that way you can see that it, HVAC system not only helps or not only helps to maintain thermal comfort, but it also helps in maintaining the proper air quality inside. Okay, so basically these two are the functions of any HVAC system, basic functions of any HVAC system, and or you can say these two are the expectation from any HVAC system. Now here you can see this shows that there is an optimum range of relative humidity in which these bacteria, viruses, and all these things can survive, right? So as a part of HVAC system, it is our responsibility to maintain the humidity in this particular range so that we can basically avoid all those bacteria, viruses, and all those. So similarly, level of CO2, okay, level of volatile organic compound, okay, or particulate matters, so or carbon monoxide, CO2. So all these factors we need to maintain in a acceptable limit. So these expected limits are given in various standards. So this two figure shows the recent standard which is proposed by ISHRAE for India. So it shows the level of acceptable level of CO2, PM 2.5, CO2, VOCs, and all other gases. Okay, for different level of satisfaction, say 90% or 80%. So basically, thermal comfort and IAQ, air quality, is to be maintained, and this is the responsibility of your HVAC system or expectation from the HVAC system. Okay, and as the previous speaker was saying that most of the one of the major technology which is governing the market right now is the VCRS cycle. Excuse me. So VCRS cycle, so which is widely used, and he and he was suggesting right that we should go for other renewable energy based or uh, low grade energy based refrigeration system or air conditioning system, because this is the requirement as far as or this can be fulfilled in India because we have sufficient amount of heat. So why he was talking about it, because in all the VCRS cycle there is one component which is the compressor, right, in all your refrigeration and air conditioning systems, and this is basically the culprit. Why? Because it consumes significant amount of energy. Okay, so this is one of the energy intensive component which consumes significant amount of the energy. So this is the history of HVAC system. As the professor was saying, the first air conditioning system was seen in 1902, and which was developed by Carrier. So and he's the same guy basically who formed the Carrier company. I think nowadays also you see air conditioning systems, split AC and all of the Carrier. Sorry. And he is the same guy who is basically responsible for the psychometric chart. So what happened is that at the end of 18th century or towards the beginning of 19th century, we had something called compressor which can be used, and based on that we can either generate cooling. Okay, we can use it for developing cold storage or developing air conditioning units. And then research in this field started. People started using different kind of compressors, different kind of refrigerators and all. And during the industrial revolution, uh, so uh, so after at least after the industrial revolution, we had sufficient amount of energy. Okay, and we also had a good standard of living. So people started, and then by the time these ACs were also commercialized, okay, and so people started using it. Okay, why they started using it? In order to obtain the thermal comfort, okay, or air quality, good air quality. So anyway, before that also, before 1902 also, we were doing it, but the ways which we were with which we were doing, or we were able to achieve thermal comfort or air quality were different. Okay, so there are various vernacular designs which exist in the literature or in India also, where the buildings itself is designed in such a way that you don't need air conditioning system, okay, in order to feel comfortable. So, but with the advent of these air conditioning systems and all, people forget to do it, and then fancy buildings came into the picture. And why it came into the picture? You design building it anyway, and by the at the end of the day, you will have air conditioning system to maintain whatever you want. Okay, so that was the reason, and people stopped applying mind. So so that way, HVAC system is a good alternative because we can maintain the environment which we like. But the thing is, it's not free, right? So it consumes a lot of energy, electricity, right? So if you see overall cost of an air conditioning system, okay, so for a 1.5 ton AC, so 14% of the cost is basically the cost of equipment, and then a very small amount is the cost of refrigerant. Then say 2% is the installation, and then rest 83% of the cost is basically going for the operation, right? So during this operation, we consume large amount of electricity. Okay, and this is a problem now. So the good thing is, as far as the HVAC system is concerned, is so I'm basically telling you both the aspects, positive as well as negative. So we have covered like what are the basic expectation from an HVAC system, which are thermal comfort and maintaining indoor environment quality or air quality. Now, what are the bad aspects or negative aspect of it? It is that it consumes significant amount of energy, right? And it is basically resulting into large amount of emissions also. Emissions can be either in the form of leakage of refrigerant. It can also be in the form of energy which is being used, because the 83% of the energy which is you are using during the operation is basically produced by some source, right? It can be a fossil fuel based electricity production. So there also you are emitting some amount of uh, uh, harmful emissions in the environment. So these two are the challenges as far as the HVAC system are concerned. So and these are significant concern nowadays, and that's the reason probably why we are still discussing HVAC system here. Okay, so I just gave you a brief indication of the challenge. Now let's see quickly. So one of the challenge which is there is the energy consumption. So sorry, I will quickly go through it. So these figures are for India. So here you can see that in India, so buildings consume around 33% of the energy. Okay. And rest of the energy is being used for industry by industry and in the agriculture. So 33% is a huge amount. Okay. And this 33% is basically going in the domestic as well as commercial use. Okay. As far as the commercial buildings are concerned, so out of this 33% which is used, okay, in buildings, and if you consider it to be 100%, so 31% of the overall building energy which is consumed, 31% of it is only consumed for air conditioning or by HVAC systems. The rest is consumed for lighting and other purpose. And as far as the residential buildings are concerned, so again, as far as the India is concerned, we are very good in using fans, evaporative coolers, okay, and till now the reach of HVAC or air conditioning systems is not good, or it's not wide in India. Okay, so I think it's around 7 to 8% of the population is currently using air conditioning in residential. Okay, so the penetration of air conditioning is not that good in India. So, but with time it is increasing because the economic status of people are increasing. So more and more number of middle class families are nowadays going for air conditioning system. So this percentage, which is currently 7 to 8%, is basically increasing, and it is expected that it will increase significantly nowadays. Why? Because if you now remember, I was talking about the heat waves, right? So now in the previous slide, I talked about a little bit about heat waves. So the environment nowadays is kind of becoming very harsh. We over a period of recent years, we have seen large number of means frequent heat waves and longer heat waves. So this is basically affecting this outdoor weather is also affecting your indoor conditions. Okay, so basically it is making the indoor environment unbearable. So which will further promote the use of air conditioning systems in India. Okay, so this number is supposed to grow very fast. And as far as India is concerned, so you know that we have a very bad state as far as the jobs are concerned. So we need to grow our industrial production. We need to industrialize, right, in order to provide job to large number of people. So now, if we have to do it, if we have to increase our service sector, if we have to increase our manufacturing sector, right, you will see that there is a rapid urbanization which will take place, or rapid urbanization which will take place, industrialization takes place. So, so people migrating from villages to the cities. Now, when people are coming from migrating from villages to cities, you need infrastructure. You need a place for them to stay, right? You need housing. So we need to create large number of houses over a period of over next few years. Okay, so that is why we have now housing for all by 2022. So considering this fact that we need to create job, right? We have to create job, and which will require rapid industrialization, okay, rapid urbanization, and rapid pace of building houses. Okay, so it means our building sector is supposed to grow significantly. Okay, so it has been found that 39% of the India of 2037 is yet to be built. Okay, so which is a significant amount of things. Similarly, when we talk about 2050, so 80% of the India is yet to be built. So it means whatever we have right now in terms of buildings, okay, so it's only 20%. Okay, so it's only 20%, and now so 80% of it is yet to come. Say if I assume that this 80% is too high, or is it's a kind of gross over prediction. So in that case also, if you assume that it's say 40% or 50%, that's also a significant amount. Okay, and so like it is like creating 68 cities with a population more than 1 million, okay, which is 42 now. And Europe, we have 35 such cities. Okay, and it also means that every year we have to create a new Chicago. Okay, so that pace of building infrastructure is required. So now, so so it is. I think it is clear from this that we need to build large amount of infrastructure, or we will have large number of commercial buildings, and we will have large number of residential building over a period of say next 20-30 years. Right. So under such circumstances, and considering that building are consuming 30% of the electricity, which we have just seen, right? So you have 50% of the building or 80% of the building coming up, and each building is consumed, or buildings are consuming 30% of it. So it means there is a huge demand of energy which is going to come, and most of it is going for HVAC applications or cooling applications. So if you see here, so space cooling is going to contribute significantly. Space cooling in buildings, which means nothing but HVAC system. Okay. So this is this is our energy consumption in the residential building. So right now is 260 terawatt hours. So it is predicted that by 2030 or 32, it is going to be 3 times higher, approximately. Okay, and space cooling is going to contribute significantly in it. Okay, so that is why it is very important for us to think about it. Okay, and obviously we need thermal comfort, we need good indoor air quality, so we need HVAC systems. But like considering the energy demand which we are going to have, okay, so we need to think some alternative, okay, or we need to go ahead with the existing HVAC system, but we need to do some intervention so that the energy efficiency can be introduced. Although the system which are in use right now are good, efficient, right? But still, we need some interventions. Either increase the efficiency of the existing system or COPs of the existing systems. This can be one of the solution, or go for solar-based space cooling, solar-based refrigeration, because we have abundant amount of solar energy in India, right? Second option, or there can be other options. You design your building in such a way that you need less amount of space cooling. So basically, we need to work on both demand as well as supply side. Reduce your demand, okay, make your supply energy efficient. So these two are the basic requirements. And this not only it's not only about energy. When we are saying that energy consumption in buildings, only the residential building is going to be is going to increase by 3 times. So it means we need to produce that amount of electricity, right? And either we will be using coal or something else. So, and most of the coal which we are using is being imported from somewhere else. So basically, it affects your economy. And when you are using coal to produce that electricity or energy, so you need, I mean, you will basically emit something, right? You will have harmful emissions which you will emit in the environment. Okay. So the ultimate solution or the good thing is to reduce your energy requirement itself. Yeah. So and this 30% which I was talking about is not only Indian phenomena; it's everywhere. Okay. So if you see here, it's like 40, 50, 30. So most of the countries, they are uh, almost consuming 40 to 50% or 30% of the energy in buildings. Okay, and you can also see that the CO2 which is emitted by the buildings, okay, is also significant. By the building, I mean the energy which is consumed or the contribution which is coming because of building can be, and it is majorly due to cooling or heating of the building. And this is a cause of concern now, as you know that we are talking about Paris agreements and all those things. We are talking about global cooling, global average temperature reduction. Okay, so this was the Paris agreement which came into picture recently. Okay, so here also all the countries have actually committed something to make it possible. Okay, so as far as India is concerned, so we have also committed a lot of things. Okay, and among them, there is one thing called building energy efficiency. So uh, there also it has been noticed or it has been recognized that building is one of the major energy major emitter or energy consuming application, right, or location. So considering it, uh, so and as a mechanical engineer, we should know that HVAC systems are basically responsible for most of. So we need to work on it. Now, having seen all the requirement what we have or why we need HVAC systems, basically to get in a crude way, I can say that in order to find out, in order to achieve thermal comfort and in order to achieve air quality, or in general, in order to achieve a better IEQ, indoor environmental quality. Okay, so we cannot go away with the from the HVAC system. So it is required. So now, since it is required, but there are some challenges associated. What are these? These are basically the high energy cost or high energy consumption, and the second one is the emissions which are coming out of it. Now the next section is what are the solutions? Okay, or in which direction people are working in order to achieve or in order to reduce that energy consumption or in order to mitigate those challenges. Okay, so the solution is to have to reduce the energy consumption. So this can be achieved broadly by either going for a sustainable HVAC system or energy efficient buildings. Okay, so I think there is you have one special lecture on this sustainable HVAC system or sustainable refrigeration. So there you will get more detail about it. So the next thing is energy efficient building. So I will be talking about briefly Okay, so when we talk about sustainable AC futures, so you know that we have various emissions coming out of it. Okay, some are direct emissions, some are indirect emissions. These can be reduced. So there are various approaches. So one of the approach is to have GWP, low global warming potential refrigerant. Okay, so this is people are doing research in this particular field. They are trying to develop refrigerant which have low global warming potential. Okay, so this is one of the area which in which people are working right now. Then there are other techniques also, which I think you will be hearing about more about it during the specific lecture. Okay, or non-vapor compression technology. So this is one of the hot areas in which we can work or you can work. Now, the second solution is to have energy efficient buildings. So when we say that buildings, how to achieve these energy efficient buildings, I think I hope it is clear, right? Why we need energy efficient building. Just now we saw that 30% of the energy is consumed in buildings, and number of buildings are also going to be increased significantly in the coming decades, right? So in that aspect, it is very important to have energy efficient buildings, basically to reduce your demand. Okay, so this is basically reducing your demand side. Okay, so this can be achieved by various ways. Some of them are you you have to use energy efficient appliances. Okay, or you have to adopt building codes. Okay, and then you need to reduce your cooling and heating loads. And fourth option is you need to increase your set point temperature. So we'll talk about them. So the first one is to use energy efficient appliances. So for that, BE is doing good work. They are introducing these Energy Star rating systems. Okay, and they have developed Indian specific rating system also recently. Okay, so just to have an idea, like say higher star rating means high energy efficiency. So that way, if you are using so you can see it from this table also. Okay, so it means in a crude way or layman's term, I can say that uh, if you are going for a high star rating appliance, be it anything like say for example AC, split AC. Okay, so in case of split AC, if you are going for a from a 3 star to 5 star, so 5 star is more energy efficient. So basically, you can reduce your energy requirement significantly. Okay, so this is one of the way to reduce your energy demand. Then second option is in the energy efficient technology is to have your intelligent control system. Okay, building management system. So so one of the major reason why we consume a significant amount of energy in buildings is our behavior. Okay, so we we are very casual, and uh, and there is a lack of information also, right? So most of us don't know, like uh, increase. I mean, it may increase your electricity bill by 100 rupees, but at the end of the day, if it is increasing 100 rupees for each and everyone, then it's a problem as a country, right? And it basically results in a significant amount of energy demand. Okay, so by adopting good behaviors or by informing people, you will not only save the energy. Uh, you will not only save the energy, but you will also save your energy bills. Okay, so anyway, so but it's for a human being, it's especially us, it's difficult to change, right? Uh, so in that case, if we since we are reluctant, so we can go for intelligent control system, basically which can Okay, so I think I have limited amount of time. So this is one of the options we can use intelligent control system, and we can save significant amount of electricity. There are studies which says that 40% of the energy can be saved. So next one is the implementation of building codes. So by forcing people to use these building codes, we can further reduce the energy consumption. So this is just to give you a glimpse. Say just by so ECBC has developed some code for commercial buildings, right? So just by employing those codes, so we can save 25% of the electricity. And recently, they have come up with ECBC, ECBC Plus, and Super ECBC. So if you employ these Super ECBC, you can save 50% of the electricity compared to any conventional building. So if you employ these codes, you can save 50% of the energy by 2030. Okay, which will basically results in saving 35,000 crore rupees, or your reduction in of 15 gigawatt power in your peak demand, and saving 250 metric ton CO2 emission. And then third option is to reduce the cooling or heating load of your building, right? So you know that if you want to calculate your HVAC cooling load, so you have these mechanism. Okay, if you sum all of this, you will get your cooling load. How much is the cooling load of your building? So this and in this, your windows contribute a significant amount of heat energy, means is transferred through windows. So basically, in the cooling load, windows can contribute significantly. And then the second is roof, and then your walls and infiltration. Internal heat gains are generally less. Okay, so these cooling load can be reduced by adopting passive techniques. Okay, you can go for natural ventilation, BIPV, or you can design your envelope in such a way that nowadays people are using insulated walls. Okay, and then it also depends on your orientation, the way you orient your building compared to the existing environmental conditions. And then cool roof or green roof, because roofs contribute a significantly in the building cooling loads. Okay, so these are some of the areas in which active research is going on right now. And the third option and the last option which I'm going to discuss is the increase in the set point temperature. So there are, I mean, as I was talking about it earlier, so generally the general conception is maintain the temperature around 25 and humidity 50%. So you will feel comfortable, but it's not true. Okay. So we Asians, or specifically Indians, we may feel comfortable even at 25 degrees Celsius also, or 30 degrees Celsius also, because we are acclimatized, right? So even at 30 degrees Celsius, we can also feel warm. So basically, instead of maintaining 25, if you maintain it 28 or 30, you are increasing your set point temperature by 3 degrees Celsius. And it has been found that just by increasing your set point temperature by 1 degree Celsius, you can save around 6 to 10% of the electricity, okay, or energy. So imagine if you are maintaining your AC not at 25 degrees Celsius and but at 28 or 29 degrees Celsius. So you can save around 25% of the electricity, okay, or energy requirement. Say this is one a typical study done in Delhi. So this shows that if you maintain your set point temperature 22 degrees Celsius and 28 degrees Celsius, there is uh, cooling demand can be reduced significantly. And there are similar studies available in the literature which also talk about. Now the thing is how to maintain or how to increase the set point temperature further. Say, as an Indian or as an Asian, I can survive at 27 degrees Celsius. That's all. Now, if I want to increase it further, how to do it? Like, say, instead of maintaining it 27, if I could maintain it at 30 or 32 degrees Celsius, my air conditioning system. Okay, so still I have 5 degrees Celsius margin, right? So this kind of 5 degrees Celsius margin can be achieved further by employing personal cooling heating systems or local cooling heating systems, along with along with your normal HVAC system. So the idea is to maintain your HVAC system at 30 degrees Celsius or 32 degrees Celsius, and meanwhile employ these personal cooling or heating systems or local cooling or heating systems. Now, what is personal cooling or heating system? So now, see, the overall idea, I think I may get just 2-3 minutes or 5 minutes maximum. I may take 5 minutes. So the idea is like what is personal cooling and heating systems. So before that, we need to know like why we need HVAC system or why we are using centralized air conditioning systems. Basically, we are using it to achieve thermal comfort. Okay, apart from this air quality. So now, what we are doing is we are using these HVAC systems or centralized HVAC systems, and we are cooling our building. Why we are cooling our building? Just to get, just to achieve thermal comfort, human thermal comfort. Okay, so rather than cooling, because who want thermal comfort? So building doesn't require it, right? It's human who require thermal comfort. So why we are cooling the entire building? That's the question. Okay, so in centralized systems and all, we cool the entire building. Say if I am sitting with 10 members in this particular room, so we are 10 guys or 11 guys. Okay, and just to obtain thermal comfort of those 10 guys in an auditorium or in a big room, I am cooling the entire room, right? But the alternative solution could be you cool yourself, because it's me who want thermal comfort, right? So rather than cooling myself, I'm cooling my entire room. Okay, so this is a waste of energy. Okay, so in personal cooling and heating system, what we do is we cool the surrounding or ambience around us rather than cooling the entire room. So this is the so when we cool only our surrounding, which is kind of close to me, so I'm not bothered about what is happening outside or far away from me. So basically, I can save a significant amount of. So that is why these are getting popular nowadays, and a lot of research is going on in this particular. Maybe I mean, if you have some doubts, you can mail me or something to discuss it further. And I would like to highlight one personal cooling system. Uh, Now, personal cooling system can be of various types, right? You can cool your chair, you can cool all those things. But nowadays, this personal cooling clothing is getting more popular. Why? Because it is portable. Means if, say, for example, in the previous case, these cases, you can see that here this guy is using fan, here you have diffusers, here you have cooling chair or heating chair. Okay, so all these things are stationary things. Say if I'm walking, I won't be able to use all of this, right? So in such portable applications, but clothing is a thing which you are wearing always. So it's basically when you are wearing a clothing, you are always carrying with you a microclimate. Okay, so if you can cool that particular microclimate, so microclimate means the region between your clothing and skin. Okay, so there is always a gap which exists. So this is called the microclimate. So rather than cooling the entire building, if you cool that microclimate which exists between your clothing and skin, that's good enough. You don't have to cool the entire building or surrounding area, right? So if you use that, you can significantly reduce the energy. Say for example, uh, if I'm talking about this one, this air ventilation clothing, it just uses 5 watt of electricity, and with just 5 watt of the electricity, you can achieve thermal comfort till 32 degrees Celsius, which is a huge achievement, right? We maintain our air conditioning systems around 25 or 27, right? If we are aware. So, which consumes one ton AC or 1 point, right? So, which is a huge amount of energy. Okay, say even at 32 also we use that 1 ton AC we can use, right, which will consume 1.5 kilowatt compared to just 5 kilowatt here. So these are portable systems, right? They can you can still achieve thermal comfort as you are getting in HVAC system, but you are dropping or reducing the energy consumption significantly. 1.5 kilowatt, 1500 kilowatt to 5 kilowatt. Imagine, it's huge. Okay, so so active research is going on in all these areas, personal cooling heating systems. So this is one of the study which we did with human trials. So we obtained that we found out that till 32 degrees Celsius, if you use this, you can achieve you can achieve thermal comfort till 32 degrees Celsius. So if you employ these kind of clothings, air ventilation clothing, along with HVAC system, you can significantly reduce the energy. Say 55 to 60% of the energy which you are consuming without this kind of personal cooling clothing can be reduced to by 55 to 60% if you use HVAC system with this kind of personal cooling system. And then we are further. So basically, this is what I was talking about. So you have a skin here, right? You have a human body here, and then you have a clothing which you are wearing outside. So rather than cooling the entire area, you just cool this microclimate which exists between your body and the clothing, right? So you can cool the air and you can circulate it around. So that way you can achieve energy efficiency and you can reduce the cooling load or the demand of the energy significantly, building energy demand. Okay, I'm running out of time. So then you have local cooling systems also. Rather than cooling the entire body, so basically it's like cooling a building, right? Cooling a room. Instead of cooling a room in personal cooling system, we are cooling a localized zone around your body, right? So this way we are reducing the energy demand. And then in personal cooling clothing, we are further reducing it by cooling only the microclimate which exists between you and your clothing, right? Which further reduce the energy demand. And now there is new technology or new area in which people are working, which is called the local heating and cooling systems. So in that case, I'm not cooling my entire microclimate. I'm just cooling a part of my body. So in this case, this guy is only cooling his wrist, right? And still they can achieve thermal comfort. So imagine, like, you can reduce the demand significantly. But anyway, HVAC systems are going to be there. Okay, and it's good that we are talking about HVAC systems. And I hope and I wish you all the best. And I hope we'll come up with some of the technologies which will make these refrigeration and air conditioning systems energy efficient and more sustainable. Okay, because this is what is required from these systems. Okay, thank you. Okay.
Thank you,
I'm
sir.
sorry that I took a lot of time.
No, sir, not an issue. We have two questions over here. So
Yes.
first one is from Jinesh Barrett. He's asking what is the range of metabolic rate of individual for comfort?
Okay, so can I go back to the slides? Yeah, so Jignesh, right?
Yeah.
Yeah, so it's like there is no range actually. So the thing is, if suppose, for example, if you have to work on a computer, say for example, if you see this particular graph or figure, so when you are simply sitting and reading something, your metabolic rate is 1 mat, which is kind of 56 watt per meter square. Okay. Whereas if you see this, you are working on a computer which is 3 mat. So 150, around 150 watt per meter square. Now, just to get the thermal comfort, you will not change your metabolic rate. Say if you are in an office, you will have to work on a computer, right? So means you will not say that I'm not feeling comfortable, and so I will stop working. So you will have to work, right? So basically, changing metabolic rate is not a good option in order to achieve thermal equilibrium or in order to achieve thermal comfort. Okay, so this is not an option. So whatever work you have to do inside the building, you will have to do, right? Say for example, if you have to work on computer, you are working there and your metabolic rate will be 3 mat, for example, right? Say 150 watt per meter square. Now you have to design your conditions or environment or indoor environment or your HVAC system in such a way that it can provide you thermal comfort at 3 mat activity level, right? So you don't have to change your metabolic rate just to get thermal comfort. You have to change your environment or your clothing in such a way that you feel comfortable. Say for example, when you are sitting, you may be wearing a jacket over your shirt, but when you are working on a computer, you are generating more heat. So maybe in that case, you can adopt some behavioral changes, okay, and you can remove that jacket and you may feel comfortable. So changing metabolic rate is generally not an option. I hope I have answered this. Hello, Aniket.
Yes, sir. So we have one more question
Yes.
from Kavikant Mahapatra. The question is the PMV and PPD loss in human being as shown in the research publication equally applied to the people in India?
Sorry, is the PMV PPD shown in?
As shown in the research publication equally applied to the people in India.
So that is what I was talking about. So yeah, so it's not the case actually. So as I was talking about earlier, so it depends. Like say for example, if you go to Europe or some other country, in a summer condition also they feel comfortable around 22 degrees Celsius also. Means this is a recorded thing, right? So even in the publication, there are few publications where people have done such kind of study, and they found out that European people, because they are not much into heat, right? They are coming from a cold environment, right? They are in a cold country. So they are in a cold country, so they feel not used to heat. So they are not used to heat, hot environment, so they feel comfortable at 22 degrees Celsius. Whereas under the same environmental condition, Indian guy may feel comfortable at 28 also. So our acclimatization is different. We have acclimatized. So in that case, uh, uh, I can't say, or I think it's not good to say that the publication which they are showing, say if they are saying between 0.5 minus 0.5 to 0.5, people are 90% of the people are feeling comfortable. So that may not be applicable to Indian population. So we may feel comfortable minus 1 to 1 or 1.2 minus 1.2, 90% of us. So that way it's not applicable, I think. But still it is being used.
Okay, thank you, sir. So we have few more questions, but due to lack of time, I think I'll mail it to you, sir, and then we can get back to them.
You can mail me, I will get back.
Yeah, okay, sir. So thank you, sir. It was a very wonderful session, and the feedback also.
Okay, thank you. Thank you for giving me the opportunity.
Yes, sir. Thank you. So, dear
Thanks.
participants, the next schedule will be starting from 12:30 p.m. So, I hope you join the session, and the remaining questions may be answered in that session also. Thank you, sir.
Okay, thank you. Thank you all.
Yeah, and we'll be joining at the same link.
Every success has its own story. And in case of PCCOER, short for Pimpri Chinchwad College of Engineering and Research, the story began from its very inception in the year 2014. We are creating this success story under the aegis of Pimpri Chinchwad Education Trust, PCET, which was established by late Shri S.P. Patil in the year 1990. The trust has the vision to provide value-added education to the society in multiple dimensions, right from nursery up to doctoral program in all professional streams. PCET is a well-established and time-tested brand in education. PCET governs 9 institutes, which include a public school, a polytechnic, a management institute, an architecture college, a science and commerce college, and 4 engineering colleges.
Pimpri Chinchwad College of Engineering and Research is one of the leading colleges of Pune University. We follow the simple principle of 5-pillar philosophy. In this 5-pillar philosophy, the academic excellence is the first and the important pillar. The second one is research and innovation. Third is the training and development aspect. Fourth is the social awareness angle, and fifth is ethics and values. As a result of this, the students are developed in all dimensions, and the college is emerging very fast among the top colleges of Pune University as well as at the state level.
PCCOER has been founded by highly qualified and proficient academicians. We are located in the most refined cluster of innovative firms at the heart of an industrial hub. Here, our students have numerous career opportunities. PCCOER runs UG courses for civil engineering, computer engineering, electronics and communication engineering, and mechanical engineering. These courses have been approved by AICTE, DT, and Government of Maharashtra. The institute is affiliated to Savitribai Phule, Pune University. PCCOER is a place of excellence where your vision comes true. At PCCOER, you can wander through the ocean of knowledge and build the courage to seize your aspirations. We merge technology and participative learning to make your education more engaging, more gratifying. PCCOER has a skilled team of experienced, highly qualified, dedicated faculties and associates. They play their crucial role in fulfilling the vision of PCCOER. We have a systematic and standardized pattern for work execution and a perfect teamwork. We have a comfortable, pleasant, healthy and friendly campus where the students can exploit their true potential. We provide a self-sufficient and sustainable environment to develop the perception of how various concepts fit in collectively. Our approach has always been student-centric, and we stay attentive to their demands. The institute building is not just a structure of bricks and mortar, it's a temple for the learners. We provide the best teaching learning processes and a research provoking ambience. We have well-equipped laboratories with state-of-the-art instruments that ensure that you are at the cutting edge of engineering and technology. Our infrastructure includes all the necessary suite of tools and software which help the students bloom.
We organize guest lectures of expert speakers from industry and reputed institutions like IITs for students as well as for faculties. We organize site visits, industrial visits in each and every subject for the students so that students are exposed to the three-dimensional engineering realities. It is also mandatory for the students to undergo internship so as to gain invaluable hands-on experience. We have smart boards, we have screens, projectors, computers in each and every classroom. We have state-of-art laboratories where we encourage the student to perform experiments, to perform tests, to develop projects, to develop working models.
The institute campus is rich with greenery and blooming flowers which lend a soothing touch to the demanding academic tasks. We have a huge ground where students enjoy outdoor sports and an open gymnasium for the fitness freaks. The indoor gymnasium has facilities for many indoor games. We have a vast library that houses more than 2,000 titles and 10,000 volumes of technical books, subscription to several technical journals, e-journals, and a large collection of literary books to cater every intellectual need. The reading hall has the ambience that motivates the students to stay focused and excel confidently. Empty stomach results in empty mind. Hence, we have excellent arrangements in the form of canteen and mess to satisfy the physical appetite of the students and staff. Other facilities on campus include covered parking, CCTVs, 24/7 security, and firefighting system. We have our own comfortably furnished hostel accommodation for boys and girls. Intellectual and psychological growth of the students is the centerpiece of PCCOER. Our students excel not only in academics but also in cultural and social events. We create various mind-feeding activities and conduct several exercises such as yoga workshop, mind education, wall magazine, self-awareness programs, inspirational programs, project-based learning, and annual gatherings. Our students participate and shine in co-curricular and extracurricular activities like Baha, Go-Kart, Robocon, Tiffin, Purushottam Karandak, Firodia Karandak, Daji Kaka Gadgil Karandak, and many more. Socio-economic empowerment of society is everyone's responsibility. PCCOER has always been a torch bearer in shouldering such responsibilities.
The students of our NSS unit regularly arrange blood donation camps. This year, our blood donation camp saw a response of about 150 blood donors. Our students regularly visit old age homes and orphanages where they feel very happy and joyous to spend time with underprivileged elderlies and children. Students regularly take part in social activities like tree plantations regarding environment, as well as various cleanliness drives as part of the Swachh Bharat Abhiyan. Part of Unnat Bharat Abhiyan for rural development by the Government of India, our college has adopted 5 villages in Mawal Taluka of Pune district.
We are equipping our students with the set of skills, capabilities, and attitudes they need to succeed as employees, leaders, and entrepreneurs in modern world.
We are probably the only institute in India which has placed it's 77% of students in first 2 batches. Around 400 plus companies give opportunity of placements to our students every year. We train our students right from second year, considering their improvement for soft skills, aptitude skills, technical skills. So recently we have conducted drive of Amazon where the maximum package given was around 28 lakhs. 2 of our students got selected in Japan for the packages of around 20 lakhs and 17 lakhs.
I'm currently working in a Japanese company, tech firm, which is located in Tokyo, and I got a package of 17 lakh. When I was in second year, the Japanese training started in our college, and our HOD was very supportive, and she was like, you should do this training because it will be beneficial in your future.
Our central placement cell has placed more than 20,000 students. We have conducted 125 off-campus drives for 33,000 students from all over Maharashtra. Here, more than 1,400 students have secured their dream job. We have also channeled 150 online recruitment examinations. We are a vibrant alliance of educators and scholars who guide and motivate the students by setting an example, not by empty words. We at PCCOER emphasize on breakthrough engineering with breakthrough results.
माझा मुलगा शिवम भावसार हा याने डिप्लोमा केलेला आहे इन मेकॅनिकल इंजिनिअरिंग. तर त्याच्यासाठी आम्हाला डिग्रीसाठी खूप चांगलं कॉलेज आम्ही शोधत होतो. त्याचं सगळं व्यक्तिमत्व फुलेल, ऑलराऊंडर बनेल याच्यासाठी आम्ही बऱ्याच कॉलेजचा शोध घेतला. त्याच्यामध्ये नाशिकमध्ये आम्हाला असं कळालं की पिंपरी चिंचवड कॉलेज ऑफ इंजिनिअरिंग अँड रिसर्च हे कॉलेज खूप चांगलं आहे. आम्ही पुण्यातले 3-4 कॉलेजमध्ये गेलो, तिथे रिसर्च केला आणि त्याच्यानंतर निर्णय घेतला की आमच्या मुलासाठी हे कॉलेज योग्य आहे.
So I decided to get my admission in this particular college, that is Pimpri Chinchwad College of Engineering and Research, for my daughter Pallavi in civil engineering. She is doing really great in academics. Not only in academics, but there are various activities like curricular activities, co-curricular activities, extracurricular activities, and even mini projects. I am really satisfied that I took a very correct and very right decision by putting my daughter in this particular college.
No doubt our college is excelling in the placements part as well as the educational part, but today I would like to put forth one more perspective, that is the higher education. I would like to mention that I'll be pursuing my Masters of Science, MS in Computer Science from University of Southern California, Los Angeles next year. I would like to mention that all my teachers, my head of the department, our principal, our Dean III of Training and Placement Cell, everyone supported me and encouraged me. Definitely I will say that with the help of this college, I have personally developed a lot.
With the combined, sincere and focused efforts of management, staff and students, PCCOER has established a world record of filing highest number of copyrights by any organization in a single day. And this grand achievement was recognized and honored by World Records India and India Book of Records. Our faculties and students have published more than 280 research papers in international and national journals of highest standing in the current academic year. PCCOER has bagged many awards, amongst which are Innovative Leader National Award, IARDO Award for Academic Leadership, Special Award for Patents and Copyrights Filing, Global Education Excellence Award for the most result-oriented engineering college, and Outstanding Upcoming Engineering College in Maharashtra.
The research and development is a very important pillar for the progress of any institute. Not only filing of patents and copyrights, we have 8 products in a market. In order to strengthen the research and development according to the industry, we have more than 20 MOUs. All these MOUs are active MOUs. Under that, each department having an industrial visit, then internship for the students, guest lectures, workshops, seminars. So these seminars and all these activities try to bridge the gap between industry and academy.
Now all this is reflected in our university results. We have started just 5 years back, and in this very short span we have achieved a position amongst top 5 best institutes in Pune University. Now for an institute in its infancy, this is a great achievement.
We at PCCOER help the students to change the world for the better through their education. We create not only brilliant professionals but also responsible citizens. Our management, faculty, staff and students have a single motto: to become a national pride. It is the very secret of our rapid growth. There is a difference between dreaming and realizing dreams. Dreams require effortless sleep, and realization requires sleepless efforts. Everything is possible for those with a vision, a plan of action, and a determination to make it happen. Be a part of PCCOER to fulfill your dreams.
Hello, good morning, sir. Audible?
Morning, yeah.
Every success has its own story.
Am I audible to
In
you?
case of
Yes, sir. Yes, you are audible.
short for
Sir,
Pimpri Chinchwad College
yes.
of Engineering
Please.
and Research.
Sir, can you
The story
share your
began
screen?
From its very
If
inception.
you start the
in the
sharing screen,
year
you can check out whether it
2014.
gets really shared or not.
We are creating this success story under the aegis of Pimpri Chinchwad Education Trust, PCET, which was established by late Shri S.B. Patil in the year 1990. The trust has the vision to provide value-added education to the society in multiple dimensions, right from nursery up to doctoral program in all professional streams. PCET is a well-established and time-tested brand in education. PCET governs 9 institutes, which include a public school, a polytechnic, a management institute, an architecture college, a science and commerce college, and 4 engineering colleges.
Pimpri Chinchwad College of Engineering and Research is one of the leading colleges of Pune University. We follow the simple principle of 5-pillar philosophy. In this 5-pillar philosophy, the academic excellence is the first and the important pillar. The second one is research and innovation. Third is the training and development aspect. Fourth is the social awareness angle, and fifth is ethics and values. As a result of this, the students are developed in all dimensions, and the college is emerging very fast among the top colleges of Pune University as well as at the state level.
PCCOER has been founded by highly qualified and proficient academicians. We are located in the most refined cluster of innovative firms at the heart of an industrial hub. Here, our students have numerous career opportunities. PCCOER runs UG courses for civil engineering, computer engineering, electronics and communication engineering, and mechanical engineering. These courses have been approved by AICTE, DT, and Government of Maharashtra. The institute is affiliated to Savitribai Phule, Pune University. PCCOER is a place of excellence where your vision comes true. At PCCOER, you can wander through the ocean of knowledge and build the courage to seize your aspirations. We merge technology and participative learning to make your education more engaging, more gratifying. PCCOER has a skilled team of experienced, highly qualified, dedicated faculties and associates. They play their crucial role in fulfilling the vision of PCCOER. We have a systematic and standardized pattern for work execution and a perfect teamwork. We have a comfortable, pleasant, healthy and friendly campus where the students can exploit their true potential. We provide a self-sufficient and sustainable environment to develop the perception of how various concepts fit in collectively. Our approach has always been student-centric and we stay attentive to their demands. The institute building is not just a structure of bricks and mortar, it's a temple for the learners. We provide the best teaching learning processes and a research-provoking ambience. We have well-equipped laboratories with state-of-the-art instruments that ensure that you are at the cutting edge of engineering and technology. Our infrastructure includes all the necessary suite of tools and software which help the students bloom.
We organize guest lectures of expert speakers from industry and reputed institutions like IITs for students as well as for faculties. We organize site visits, industrial visits in each and every subject for the students so that students are exposed to the three-dimensional engineering realities. It is also mandatory for the students to undergo internship so as to gain invaluable hands-on experience. We have smart boards, we have screens, projectors, computers in each and every classroom. We have
Hello, good morning all. We are having next speaker into the session, Professor M. Ram Gopal. I think those who are working in the field of refrigeration and air conditioning and human comfort, everyone is well known about Professor M. Ram Gopal, but still I would like to introduce for these people who are not aware of, in case if they are new into this field. Professor M. Ram Gopal has received his BTech degree in mechanical engineering from REC Warangal, which is currently known as NIT Warangal. He has completed his MTech and PhD degrees from IIT Madras. Currently working as a professor in the Department of Mechanical Engineering, IIT Kharagpur. He has more than 25 years in the area of refrigeration and air conditioning. First as a senior project officer at IIT Madras, followed by the manager of R&D in PPL Refrigeration Limited, and now as a professor at IIT Kharagpur. He has handled several small, medium, and large air conditioning projects as professor in charge, refrigeration and air conditioning at IIT Kharagpur. He is in charge of a well-equipped laboratory with the state-of-the-art measurement and calibration equipments, climate chambers, and all relevant softwares. Past the member of editorial board of Elsewhere Journal, Building and Environment from 2012 to 2018, member of Science and Technology Council, International Institute of Refrigeration Commission B2, affiliate member of ISHRAE, life member of ISHMT, IEI,
and member, Technical Committee, ISHRAE 2018 to 2020. He has supervised several doctoral and postgraduate students' theses and handled several sponsored and consultancy projects. He has published more than 100 research papers in reputed national and international journals, conferences, and proceedings. So this is what the brief introduction of Professor Ram Gopal. So I would like to transfer the session to Professor Ram Gopal. Sir, please.
Thank you, Dr. Aniket. Good afternoon, ladies and gentlemen. I hope all of you are at home, safe and comfortable. Of course, coronavirus poses challenges for remaining safe and comfortable simultaneously. Probably you might have heard in the beginning, there were suggestions that if you want to stay safe from corona, you should switch off our air conditioners. So there was a feeling that air conditioners spread infections. So it is not good if you have corona. So considering the hot summer, it is really a challenge to remain comfortable without air conditioners. At the same time, stay safe from corona. So you can see how air conditioning is affecting. So it is actually a challenge, and I hope all of you realize the challenges faced by people who wear very heavy personal protection gear, which increases their discomfort levels to a great extent. So the topic that I'm going to talk about, in my opinion, is quite relevant and it's timely. First of all, I would like to thank uh, host for inviting me. So I'll start the presentation. So nowadays, providing thermal comfort is no longer considered as a luxury. People feel that it is a necessity. Houses have to be comfortable. And in modern buildings, as all of you know, the thermal comfort is generally provided by installing air conditioning systems. And in India, if you look at the statistics, it is found that more than 20% of the total electricity consumption is because of air conditioning. And what is worrying is currently only 2% of the population own air conditioners. So you can imagine what will happen if all 100% own air conditioners, what will happen to our energy consumption. So if it is under the business as usual model, it is expected that the building electricity consumption will increase to by 8 to 10 times by 2030 if we don't do anything and just go on installing air conditioners. So at the same time, we also want people to live in a comfortable houses. So it is a challenge to provide thermal comfort at the same time handle the problems related to energy. So it is felt that we require sustainable solutions to address these twin problems of providing thermal comfort and taking care of the energy issues. So a proper understanding of human thermal comfort is needed to address these problems. So let us look at the thermal comfort. Uh, all of you know that we know when we are comfortable or we are not comfortable, but if somebody asks us to define thermal comfort, it will be a bit difficult to put it in words. So this is also faced by the scientists and engineers. There are several definitions for thermal comfort, but the definition shown on the screen is currently the most well-known and accepted definition. This is by ISHRAE standard 55. You can see that the thermal comfort is defined as a condition of mind that expresses satisfaction with the thermal environment and is assessed by subjective evaluation. So even though it looks like a simple statement, you have to notice that it talks about the condition of mind, it talks about the satisfaction. So condition of mind and satisfaction are psychological issues and they may vary from person to person. And it is very difficult to express them in terms of equations and numbers. So this is a problem faced by the thermal environment engineers. And because of this issue, generally the thermal comfort has to be assessed finally by subjective evaluation. Subjective evaluation means you have to conduct survey and find out whether people are really comfortable or not. So it is not really understood why a human being feels comfortable or uncomfortable. If somebody asks us why are we feeling comfortable, again, as I said, it will be difficult for us to explain why we are comfortable or why we are not comfortable. But it is well understood that our comfort or discomfort has something to do with the thermal environment. So this is something which is known to people. That means the thermal environment can make people comfortable or uncomfortable. And it is also well known that if people are uncomfortable, then it may affect their productivity, it may affect their performance, it may also increase absenteeism in schools, factories, etc. These facts are well documented. Since people are interested in achieving good productivity, good performance, etc., so for the last 100 years or so, when the industries have become important, people have been trying to find out the exact environmental conditions which ensure thermal comfort. So this has been the focus of intense study for the past century or so. And here the emphasis is not on why people are comfortable, but because as I said, it is very difficult to explain why somebody is comfortable or not comfortable. But the emphasis is on what produces thermal comfort. So we are essentially interested in producing thermal comfort. Okay, why it is producing comfort is not of our interest. So suppose, how do we predict whether an environment is thermally comfortable or not? So for this, a variety of techniques are used. There are several models of human body. These models are called as thermal models. And these models are supposed to represent a living human being, taking into account the heat transfer between the body and the surroundings. And the model also has to take into account the thermal properties of the body and the human thermoregulatory system, which, as you know, maintains the body temperature. And most of these models finally predict what is the temperature distribution inside the body. Okay. And these models can be divided broadly into two types. One is what is called as a steady state model. As the name implies, a steady state model means it is the body that steady state. So nothing is varying with time. Okay. There are also transient models. That means the temperature of a particular part of the body varies with time, and temperature also varies from part to part. So these are the transient models. And there are also other ways of classifying the models. It is based on how we are dividing the human body. So depending upon how we are dividing the human body, we can have a single load model, multi-load model, etc. For example, in this figure, you can see here, this is a single segment. A human body is treated as a cylinder. So this is only one segment, right? Whereas this one is a multi-segment model. That means the body is divided into several parts. Okay. So this is, that means you can see that head is a part, then hand is divided into three parts, like that. Okay. So there's a difference between single segment and multi-segment. Again, within each segment, you can have what is called as a two-node model. Two-node model means each segment is divided into core and skin. So this is what is called as a two-node model. Okay. And the more complex model is called as a multi-node model. So in a multi-node model, each segment is divided into more parts. For example, you can see that there is a core, there is muscle, there is fat, there is skin, etc. Right? So you can have a multi-segment, multi-node model consisting of several layers, several parts, etc. Okay. For example, this is one of the earliest human body models. This is a 25 node model, and it is proposed in 1977 by Stolvik and Hardy. You can see that in this model, the human body is divided into 6 segments. For example, head is one segment, torso is one, and then hands are 2 segments, 3 and 4, legs are 5 and 6, etc. And each segment is divided into 4 parts: core, muscle, fat, skin. So you have 6 segments and 4 nodes, 6 into 4, 24. And then this blood, which circulates amongst all these, is the 25th part. So this is one of the earliest multi-node, multi-segment model. Of course, later this model is improved. Nowadays, you have a 65 node model, 250 node model, infinite node model, etc. Okay. The purpose of all these models, which you can easily imagine, are fairly complex in terms of the mathematics and the physics. They are not really meant for predicting thermal comfort, but they are meant for finding out the response of the body to very unusual circumstances. For example, if you are designing clothing for a military personnel, a military personnel has to work in very cold environment, and you are designing clothing. So we would like to predict if he is wearing a particular type of clothing, how the body temperature varies or how it is distributed. Okay, so there are several applications of these models. In actual thermal comfort, we don't use, or right now we don't use this kind of complicated model. We use a simple model. Okay, and most of these models are transient models. That means they predict the temperature as a function of time and space. So the model we are really interested is what is called the Fanger's heat balance model. This model is proposed by Fanger in 1970, and it is a steady state model. And what is the objective of this model? The objective of this model is to aid engineers in deciding a combination of environmental parameters which provide thermal comfort to a large percentage of a given group of individuals. So here again you have to see this is a model is developed for a very practical purpose. As you can see that its purpose is to help the engineers in finding out the environmental parameters which can provide thermal comfort to a large percentage of a given group of individuals. Okay, it doesn't say that the aim is to provide thermal comfort to all. Later we will see that it is impossible to satisfy everybody. Okay, so this is the purpose of Fanger's heat balance model. And this is the most important model in terms of its impact, because almost all the thermal comfort standards that are followed all over the world for air conditioned buildings are based on this model. So I can say that this is the single most important model as far as the thermal comfort standards of air conditioned buildings are concerned right now. So what are the conditions necessary for human thermal comfort? I have been mentioning the thermal comfort, but what exactly makes a human being thermally comfortable? So Fanger has carried out extensive studies, and he has shown that the necessary physiological conditions for human thermal comfort are, there are three conditions. The first condition is that there has to be a heat balance between the body and the surroundings. That means whatever heat the body is producing, it should be able to boost the surroundings. Okay. So this condition is called as a neutral condition. So when you say that a human being is a neutral condition, that means there is no net storage of heat. Whatever heat he is generating, he or she, it is being rejected to the surrounding. So Fanger found that this is the first necessary condition for thermal comfort. And he also found that in addition to this, for a person to be thermally comfortable, the core and skin temperatures should be within very narrow limits, and the sweat rate also should be within a range. So the thermal comfort depends upon these three conditions. That means there has to be neutral condition, core and skin temperature should be within narrow limits, and the sweating rate also should be within a range. It should not be too high or too low. Okay. In addition to this, Fanger also found that there should not be any significant local thermal discomfort. That means it is possible to satisfy all the above three conditions, but the person may not be feeling comfortable locally. That means his neck is facing cold air, neck is warm, feet are cold, etc. Right? So there should not be any local thermal discomfort also. So these are the three basic conditions based on which Fanger has developed this thermal comfort model. Okay, so now let us look at this model. So basically, what is the heat balance for a human being? You can see that, as all of you know, a human being, a living human being, continuously generates heat because of what we call as the metabolic metabolism. So as you know that the metabolism means the process in which the chemical energy is converted continuously into heat and work. So heat is continuously produced in a human being. And the human being may also gain heat from external sources. For example, if he is standing under sun, then due to radiation, he may be gaining some heat. Or if he's facing hot air, then due to convection, there may be some heat transfer. Also conduction, if he's standing on a hot, warm floor, then there may be conduction. So you can see that a body is gaining heat by all these mechanisms, right? So this is the heat gain. And as Fanger has mentioned, this heat gain has to be exactly balanced by heat loss, right? So you can see that a human being has to lose whatever heat he's gaining. Okay, and the heat loss takes place again by different mechanisms. He can lose heat by radiation to the surrounding surfaces. He can also lose heat by convection to the surrounding air. He can also lose heat by sweating and evaporation, okay, and to small extent by conduction. Okay, so you can see that on one side you have heat gain, and the other side there is heat loss. And when they are exactly balanced, you say that the human being is at neutral condition. Okay, so this is the heat balance. So if you are considering a human being as a thermodynamic system, and if you are applying the first law of thermodynamics to the human body, we write the energy conservation equation. So you can see that in this energy conservation equation, what we have is this side, the left hand side, either a net heat that is released, and on the right hand side is some part of the heat that is released may be converted into useful work. So W is the useful work done by the mechanical work done by the human being, and some part of the heat produced may be transferred to the surroundings, and the remaining part is stored in the human being. Okay, so you have a heat generation on one side, and the other side work production, heat transfer, or heat storage. So as I've already explained, in this term, M is the metabolic rate. The metabolic rate depends upon the activity, and it can vary from as low as 40 watt per meter square to as high as 1200 watt per meter square. And as I said, QTR is the heat transfer to the surrounding, and the heat storage rate is Q storage. Okay. And W is the mechanical power output from the body. You know that we can also do some mechanical work. We can lift weight, we can go up a gradient, etc. Okay. So this is the energy balance equation. Okay. Now, for example, if you look at the typical metabolic rates as given in the ISHRAE standard, as I mentioned already, the metabolic rate depends upon the activity, and the unit for metabolic rate is called as a MET. Okay, you can see that one MET is roughly equivalent to 58.2 watt per meter square. Here, the denominator meter square refers to the body area of the human being. So you can see that for different activities, you have different metabolic rates. Okay, I have just shown very few activities. So you can see that if a person is sleeping, then he'll be generating about 40 watts of heat due to metabolism. If he's seated quiet, around 60. He's walking, it can vary from 150 to 220, etc. So these metabolic rates are carefully determined from experiments, and they are recorded. And the knowledge of metabolic rate is very important, because ultimately we have to design the air conditioning system or the room in such a way that whatever heat is being generated due to metabolism should be lost to the surroundings. So we must know how much heat is being generated. So for that, we need to know what is the metabolic rate. Also, the metabolic rate finally becomes a load on the air conditioning system, because whatever heat a person is generating and losing to the surrounding ultimately becomes a load on the air conditioning system. So for the air conditioning load calculation also, we need to know the metabolic rate. Okay. I've already mentioned that in the metabolic rate is given in terms of watt per meter square, and the meter square I said refers to the surface area of the human body. Okay. For simple comfort studies, a human being is treated as a cylinder with uniform heat generation. Okay. The human being is a complicated system, so we are assuming that this complicated system can be treated as a cylinder of uniform heat generation. Okay. And this cylinder has a surface area given by this expression. So you can see that in this expression, the body area is a function of the body mass, M is the body mass, and H is the height of the human being. Okay, so if you know the height and the mass, you can calculate what is the surface area of the human being. And if you know the metabolic rate in terms of MET, then multiplying MET into the surface area will give you how many watts of heat is generated. Okay. So in this expression, M is in kilograms and H is the height of the human being, that is in meters. Now, as I already mentioned, the Fanger's model is a steady state model. That means it assumes that whatever heat is being generated is lost to the surroundings and no heat is stored in the body. Okay. strictly speaking, a human being is never under perfectly steady conditions because something or other may be changing. Either the external conditions are changing, or the human being himself may be doing some activities continuously, which is leading to continuous change of heat generation. Okay, so general statement is human being can never be at steady state, but we can simplify this one because the variations can be neglected if you are keeping the environment fixed. Suppose I am installing an air conditioning system which is maintaining the conditions constant, and the human being is also not changing his activity, posture, etc. Is sitting quiet. Okay, in that case, we can assume that the human being is at a steady state. Why are we discussing this? Because as you can easily imagine, the steady state models are easier to handle. So unsteady state models are more complicated mathematically. So we are interested in steady state models. Okay. So almost all the thermal comfort standards that are used for buildings are based on the steady state model. As I've already said, they are based on the Fanger's model. That means they assume that the human being is at steady state. Okay. So under steady state, as I've already mentioned, there is no net storage of heat in the body. That means the body is at neutral equilibrium. So at neutral equilibrium, the metabolic rate should be transferred to the surroundings. And most of the time, for air conditioning environments, the work output is generally zero. So we can neglect the work output. So if you are neglecting the work output and assuming steady state, then you can write the energy balance in this form. So the metabolic rate is equal to the heat transfer rate, and the heat is transferred from a human being from the skin and through respiration. Okay, so these are the two mechanisms by which a human being loses heat from the skin and through respiration. Okay, so the metabolic rate should be equal to heat transfer rate from the skin and the respiration heat loss. Okay. And from the skin, heat is lost, as you know, by convection, radiation, and evaporation. Most of the time, we don't consider conduction because the heat lost by conduction is generally much smaller compared to the other mechanisms. So we generally neglect conduction, but there may be some applications where conduction could be important, right? But most of the applications, conduction is not so important. So conduction is not considered here. So we are just considering only convection and radiation and evaporation. So if you are considering these two, the heat loss from the skin, this is the heat loss from the skin is equal to the convective heat transfer rate, radiative heat transfer rate, and evaporative heat transfer rate. So you can see that the convection and radiation can be positive or negative. That means they can be heat loss or heat gain. That means a human may be gaining heat or losing heat by convection and radiation, whereas the evaporation is always positive, right? So you can see that since evaporation rate is always positive, it is possible to balance this equation even though convection and radiation are negative. So as I mentioned, we are assuming a human being to be a uniform cylinder. So we are assuming that the human being is a uniform cylinder. He's generating m amount of heat per unit area, and he's in a surroundings. These surroundings are indicated in terms of the air temperature, surface temperature, vapor pressure of water. Okay, and he's losing heat by evaporation, convection, radiation, etc. So first, let us consider the sensible heat transfer processes. That means what is the heat transfer rate by convection? All of you know this the well-known equation. The convective heat transfer rate is given in terms of the temperature difference. So temperature difference between the skin and the surrounding air, and the total resistance to heat transfer. And the resistance to heat transfer consists of two parts. One is the first part, is the resistance offered by the convective heat transfer coefficient. And if the person is wearing clothes, the clothes also offer a resistance. So this is the resistance offered by the clothes. So the convective heat transfer is given by temperature difference divided by the total resistance consisting of convective heat transfer resistance and the clothing resistance. So the same thing is actually same way. You can also write an equation for radiative heat transfer. So radiative heat transfer you can see is again given in terms of the temperature difference and resistance to radiation. Okay. In the same manner, you can also write the evaporative heat transfer in terms of the potential. For evaporation heat transfer, the potential is the vapor pressure difference between the skin surface and the surroundings. You can see that we see the potential for evaporative heat transfer. And just like convection and radiation, for evaporation also, there is the resistance offered by the surface fill and resistance offered by the clothing. Okay. So all these heat transfers are expressed in terms of potential and the resistance. And you can see the equivalent resistance diagram here. Okay, so you can see this is the skin, and heat is transferred from the skin to the surface of the clothes, and from the surface of the clothes, heat is transferred parallelly by radiation and by convection. Okay, so if you know the resistances and if you know the temperatures, you can calculate what is the heat transfer rate from the skin to the surroundings by these mechanisms. And the nomenclature is given here. Most of the time, it is helpful for if you combine convection and radiation, because both are sensible, so we can combine them. We can combine them by defining what is called as an operative temperature and a combined heat transfer coefficient. For example, if you consider a simple case of an unclothed body, that means a human being is not wearing any clothes, then you can see that convective and radiative heat transfer can be written, can be combined. Okay, and it can be written in terms of the total overall temperature potential, in terms of the operative temperature, and the total resistance, which consists of conduction and radiation. Instead of writing this in terms of resistance, we can write this in terms of a combined heat transfer coefficient H naught. So the convection and radiation heat transfer are given by H naught into T skin minus TOP. TOP is your operative temperature. Okay. This I've already explained. And you can see the definition of operative temperature here. The operative temperature is nothing but weighted average of convection and radiation. Here Hc is the convective heat transfer coefficient and Hr is the radiative heat transfer coefficient. Ta is the air temperature, Tr is the mean surface temperature. Okay, so this equation is for a unclothed body. If it is a clothed body, all that we have to do is we have to introduce the additional resistance of the clothes. So you can see when you are comparing these two equations, we have an additional resistance that is coming because of the clothes, that is given by RCL. Okay. And there are a lot of research on evaluating the heat transfer coefficient from the human being surroundings. You can see that this table from ISHRAE handbooks will give you the expressions for heat transfer coefficients for different conditions, okay, and for different limits, right? Using these heat transfer equations, one can calculate what is the convective heat transfer coefficient between the human body and the surroundings. Okay, so that is given in this table there. Next, for radiative heat transfer coefficient, we use a simple equation here. This equation gives you what is called as a linearized radiative heat transfer coefficient, and this is written in terms of the clothes temperature and the mean surface temperature. Mean surface temperature is also called as a mean radiative temperature, and here epsilon is the emissivity of the surface, and AR by AD is the exposed surface area to the total surface area. So that is what is defined here. AR is the effective radiation area. Okay, all these I've already mentioned. So in this TR is what is called as the mean radiant temperature. The mean radiant temperature is nothing but an effective temperature of a fictitious surroundings which have a uniform temperature and which give rise to the same amount of radiative heat transfer as that of an actual surroundings. How do we calculate this? This is calculated by this equation. If you remember radiation, you must be remembering what we call as radiative view factors. So these are all the view factors between the human being and the ith surface, and Ti, the temperature of the ith surface. Okay. So if you know the view factor between the body and each surface temperature, then you can calculate what is the mean radiant temperature. Once you know the mean radiant temperature and clothes temperature, you can calculate what is the radiative heat transfer coefficient. Okay. The calculation of radiative heat transfer coefficient by this means is very difficult. So in practice, what we do is we use a simple instrument called as a globe thermometer. So this globe thermometer looks like this. You can see that a globe thermometer is nothing but a normal thermometer whose bulb is inserted into a hollow globe, and the globe is painted black. So this globe is supposed to represent a human being, and the temperature indicated by this globe thermometer is called as the globe temperature. So once you know the globe temperature, then using the basic equations, the mean radiant temperature given by this equation, you can see that in this equation, we are measuring the globe temperature using the globe thermometer, and V the velocity of surrounding air, which you can measure by using an anemometer, and TA is the air temperature. So if you know the air temperature, and if you know the globe thermometer reading, and if you know the air velocity, you can calculate what is called as the mean radiant temperature. Once you know the mean radiant temperature, you can calculate the radiative heat transfer coefficient. Okay. So this is as far as sensible heat transfer is concerned. Now we have evaporative heat transfer. As I've already mentioned, this also looks like convective heat transfer coefficient expression. So here you have a resistance offered by the surface film, and this is the resistance offered by the clothes to evaporation, and this is what called as the skin wetness fraction. Okay. And from the heat and mass transfer analogy, people have established a relation between the evaporative heat transfer coefficient and the convective heat transfer coefficient. If you know the convective heat transfer coefficient, then you can find out the evaporative heat transfer coefficient. And once you know the clothing resistance, then you can easily calculate what is the evaporative heat transfer rate. Okay. So at this point, I would like to quickly mention the important role clothes play in human heat transfer. All of us are familiar that clothes play a very important role in heat transfer of human beings. They essentially clothes offer resistance to heat transfer. Okay, so when we are modeling as a human being, we have to consider the resistance offered by the clothes, because most of the time this resistance can be the dominating resistance. Okay. But unfortunately, if you want to consider the clothes very accurately, as all of you know, that the entire body is not covered with clothes. For example, head may not be covered with clothes, hands may not be covered with clothes. Only some part of the body are covered with clothes, and other parts are not covered with clothes. That means there is a non-uniform distribution. Okay. However, for in simple models, what we do is we calculate the resistance of the clothes, and it is distributed uniformly over the entire body. So this way, we can simplify the calculations. Okay. As you know, when you are wearing clothes, you are increasing the heat transfer resistance. Not only that, the clothes may also increase the body area, right? So we have to consider the decrease in the heat transfer coefficient and increase in the body area when we are calculating the heat transfer from a clothed body. Okay. So clothing resistance is given in terms of a unit called as kilo. You can see the unit for clothing resistance is kilo. 1 kilo is roughly equal to 0.155 meter square Kelvin per watt. That means in SI units, this is the value of 1 kilo. Okay. And normally we don't wear a single piece of clothing. We wear several pieces of clothing. So when we are wearing several pieces of clothing, what is the total resistance of this thing ensemble? The total resistance of the ensemble in a simple model is calculated by simply combining the clothing resistance of individual parts. So you can see that for a male, these are all the individual parts. And this is the resistance of this part, this is the resistance of this part, etc. So the total resistance of this clothing as an ensemble is simply the sum total of all these. Similarly for female. Okay. And this table again from ISHRAE fundamentals, you can see gives a large amount of data for clothing resistance for different pieces of the clothes. So once you know, or if you can guess what type of clothes people wear, then from this table you can estimate what is the resistance of the clothes which is required in the calculations. Okay. Finally, we also have a small amount of respiration heat transfer. Respiration heat transfer, as you know, when we breathe air in, which is at some condition, and the air that we breathe out is at a different condition. Because of this, there is some heat transfer. This heat transfer is called as a respiration heat transfer. So here you can see the expression for sensible heat loss due to respiration and the latent heat loss due to respiration. And in this equation, this is the temperature of the air that we are breathing out, and this is the temperature of air that we are breathing in. And this is the respiration rate. That means what is the rate at which we are breathing air. Okay. Similarly, the latent heat transfer due to respiration is given by this equation. Okay. And the respiration rate from the measurements are shown to be a function of the body area and the metabolic rate. So if you know the body area and the metabolic rate, using this equation, you can calculate the respiration rate. And the respiration rate, when you use this equation, the units are in kg per second. So once you know the respiration rate, and if you know the temperature of the air that you are breathing out and the surrounding air temperature, you can calculate the respiration loss due to sensible and latent means. Okay. So as I said, Fanger from his studies has shown that for physiological conditions required for human thermal comfort are the three conditions which I already discussed. The first condition is that there has to be a neutral equilibrium. So neutral equilibrium we are writing now in terms of the heat generation on one side and heat loss are gained by convection, heat loss are gained by radiation, heat loss by evaporation, and heat loss by respiration. Okay, so this is the heat balance equation under neutral conditions. And he found that for a human being to be comfortable, the skin temperature should satisfy this equation. So you can see that the skin temperature again is given as a function of the metabolic rate and the work produced by the human being. Okay, so if you know the metabolic rate and work, you can calculate what is the skin temperature required for thermal comfort. And he also found that the evaporative heat transfer for thermal comfort due to regulatory sweating should satisfy this equation. Okay, that means the Fanger thermal comfort model, which is valid for metabolic rate less than 3 MET, has to satisfy all these three equations. Okay, so from these three equations, Fanger has developed this what is called as the heat balance equation. Okay, so this is the heat balance equation of Fanger. So if you are putting all the terms in the heat balance equation, you will finally find that this equation can be put in this functional form consisting of 6 parameters. These 6 parameters consist of 4 environmental parameters. The 4 environmental parameters are the air temperature, surrounding surface temperature, moisture content, and the air velocity. And there are 2 personal factors, metabolic rate and clothing resistance. So the final heat balance equation of Fanger consists of these 6 parameters. Okay. So you can see that this equation can be satisfied by a combination of any 6 parameter. I mean, you can have infinite combinations which satisfy this equation, and all those combinations are supposed to provide thermal comfort. So that is the philosophy of this equation. Okay. So this is the actual equation derived by Fanger by putting all the terms into those equations. So you can recognize the terms for radiation, for convection, sweating, respiration, etc. So equation 63 is nothing but the heat balance equation. And this in this equation we require the clothes temperature. For the clothes temperature, he has given an additional equation called equation 64. Okay, and equation 65 and 66 give you the heat transfer coefficient and the ratio of the clothed surface area to unclothed surface area. So these equations 63 to 66 comprise of the Fanger's heat balance equation, which again I am repeating is a steady state equation and is valid for metabolic rate less than 3 MET. Okay. And this is if the in equation 63, if left hand side is not balanced by the right hand side, that means for a particular environment, it so happens that the left hand side is not equal to right hand side. The left hand side is not equal to right hand side, which means that a human being is subjected to thermal load. And this thermal load is simply defined as the difference between the left hand side and right hand side of the heat balance. Okay. So based on this heat balance equation, Fanger has predicted the thermal comfort. Okay, let us quickly see how he has predicted the thermal comfort. So the first step in the prediction of thermal comfort is to define an index called as the predicted mean node. This predicted mean node, or called as PMV, is nothing but the thermal sensation out of a large group of occupants. What is thermal sensation? For this, he has made use of the ISHRAE 7-point thermal sensation scale. Okay, so this is ISHRAE 7-point thermal sensation scale. You can see that this scale varies from -3 to +3, and the sensation varies from cold to hot, right? So if a human being, when you are surveying, if he says that he is feeling slightly cool, that means his PMV value is -1. Okay, and if somebody says that he's feeling warm, then the PMV value is +2, right? So by asking the people, I'm sorry, there is some problem and it suddenly stopped. Please bear with me. I think there is a problem. Hello?
Yes, sir. First screen is available. First slide is visible now.
Okay. Can you see the slides now?
Yes, sir.
Okay.
PMV is great.
Okay, so this Fanger has made use of this thermal sensation scale, and he called this index as predicted mean note. And if you conduct a survey of large number of people, and depending upon what each person is saying, his thermal sensation, you can assign a value of PMV to that person, and finally you can take the average PMV for that entire group, and you can find out what is the predicted mean note for that group of people exposed to a particular thermal environment. And Fanger, from his experimental studies and from the mathematical model, he has found that this PMV is related to the thermal load and the metabolic rate by this equation. So you can see that the PMV can be calculated if you know what is the thermal load and if you know what is the metabolic rate. Thermal load, as we have shown in the earlier slides, can be calculated if you know what is heat generation rate and what is the heat loss. So from calculating heat generation and heat loss, you can get the thermal load. And if you know the metabolic rate, then you can calculate the PMV for that group of the people. Okay, so this is the first index. Then what he has done using this index, he has calculated a very important index called as predicted percentage dissatisfied, or PPD. What is PPD? PPD is nothing but the percentage of occupants who are likely to be dissatisfied with the thermal environment. You have to notice that is not, it is likely. That means it is not certain, but most likely people will be dissatisfied. Okay. A certain percentage of the people will be dissatisfied, and that value is given by the PPD. Okay. And Fanger, again, from his studies, has found that this PPD is a function of the PMV. Okay. So PPD is a function of PMV. So if you know the value of PMV from the previous equation, you can calculate what is the value of PPD. Okay. So this PPD PMV equation can be expressed in graphical form by plotting the PPD versus PMV. You can see that this curve is symmetrical about PMV of 0, right? So it can vary from 100, 100 to 100. Okay. And you can see that when PMV is 0, PPD is 5, right? From this equation also you can easily see when PMV is 0, PPD is 5. What is meaning of PMV 0? PMV 0 means the human beings are at neutral condition. That means they are neither storing heat nor losing heat. That should keep them comfortable. But studies show that even though you are ensuring neutral condition, at least 5% of the people will always be dissatisfied. Right? So it is impossible to satisfy 100% of the people in any group, in any environment. That is what the equation for PPD signifies. Okay. And if you are designing an air conditioning equipment, air conditioning system for very sensitive application, generally we tend to maintain the PMV from minus 0.5 to plus 0.5. Okay, so this is the range which we normally use for sensitive application. But for normal applications, the PMV is typically maintained between about minus 0.8 to plus 0.8. That means you allow at least 20% of the people to be dissatisfied. It is not necessary that all 20% people will be dissatisfied, but that is the maximum you are willing to accept. Okay, so this is the basis of the PMV PPD model. You calculate PMV using the mathematical equations and the environmental parameters and the heat balance equation, and then using the PPD PMV equation, find out what is the PPD. Okay, so this is the basis for Fanger's model. Fanger has done extensive studies. He has actually spent his lifetime with these studies, and he has validated these studies by carrying out experiments and measurements all over the world in many countries. Okay, and as I said in the beginning, Fanger has a very practical purpose in his mind, and his aim is to help the HVAC industry in controlling the spaces in such a way that a large number of people will be comfortable. Okay. And this model is not valid for all kinds of conditions. This table shows what is the validity range for each of the parameters. For example, you can see that this model is valid for an air temperature varying from 10 to 30 degrees, mean radiant temperature 10 to 40, etc. Right? So you are not supposed to apply these model outside these conditions. Okay. So Fanger's comfort model developed 50 years ago, and he has validated it by large number of experiments, etc., all over the world, and it is accepted by almost all the important bodies. Okay, but subsequent studies carried out by researchers shows that there are some differences between the predictions and the actual observations. So what are these differences? it is seen that if you move away from the neutral condition, then the calculated PMV value is generally higher than the actual PMV value. This is one of the observations. And generally, it is found that the preferred conditions are not necessarily equal to the neutral conditions. Right? That means a human being is at a neutral condition, but he would like to be warm or he would like to be cold, cooler. Okay, so his preferred condition is different from the neutral condition. And in Fanger's thermal comfort model, you might have noticed that the outdoor temperature doesn't appear as a parameter. Okay. But many studies show that, especially in non-air conditioned buildings, outdoor temperature does affect the sense of thermal comfort. Okay, so this is one of the shortcomings of Fanger's model, which doesn't take into account outdoor temperature. And Fanger's model predicts that most of the non-air conditioned buildings have to be uncomfortable. But studies show that people are not so uncomfortable in buildings which are not air conditioned. Okay, non-air conditioning doesn't mean that they have to be uncomfortable. So these are some of the differences found between his model and the actual observations. One of the major explanations for this is by a fact called as adaptation. What is adaptation? Adaptation means if a person is not comfortable, he'll try to make himself comfortable. That means he'll try to adapt to the surroundings. So this is a parameter which is not there in the Fanger's model. Okay, this leads to some difference between his predictions and the observations. Okay, so based on this observation, a parallel philosophy has developed. This is called as an adaptive thermal comfort model. Okay, what is the basic philosophy of the adaptive thermal comfort? As I've already mentioned, if a change occurs in the surroundings which cause discomfort, then people will tend to restore the feeling of comfort by just resorting to some changes. Okay, so always they try to remain comfortable. So what are the changes they can resort to? For example, these changes can be physiological changes, they can be behavioral changes, they can be psychological changes. Okay, but most of the time, a person more often makes use of the behavioral changes to keep himself or herself comfortable. What are the behavioral changes? He can change his clothes, he can change the posture, he can open a window or close the window. So these are the things he'll do so that he'll find the surroundings comfortable. Okay. So these adaptive thermal comfort models have been again validated through extensive field studies, and studies show that you can through a suitable combination of adaptive actions, it is possible to achieve an acceptable degree of comfort. Okay, and this range is much larger than the PMV model. Okay, and it is possible to achieve this adaptive thermal comfort through passive building. It is not necessary to install an air conditioner. Okay, so by simple measures, it may be possible to achieve thermal comfort if you are allowing a human being to adapt. Okay, so this is the fundamental philosophy, and based on this philosophy, the adaptive comfort equations are generated. Okay, now let us quickly look at the thermal comfort standards. What are the current practices? For thermal comfort standards are based upon the buildings, and buildings can be divided into three basic types. So one is what is the normal building, which what is called the free running building or naturally ventilated building, which doesn't have any air conditioning system. The second type is an air conditioned building. Okay, and the third type is called as a mixed mode building. Mixed mode building means the building has provision of air conditioning, so it can operate as a naturally ventilated building or an air conditioned building depending upon the requirements, and it will have windows which can be opened, etc. Okay, so these are the three building classifications, and there are three important thermal comfort standards which are recognized all over the world. The first one is ISO 7730. Is an international standards organization proposed by them. Then very important thermal comfort standard is ISHRAE 55. This is American Society for Heating, Refrigeration and Air Conditioning. And there is also a European standard EN 15251. So these are the three very popular thermal comfort standards, okay, applicable to indoor spaces. Okay, let us quickly look at what do they say. For example, ISO 7730, this table gives the standard. Okay, so in this standard, the buildings are divided into three classes: class A, B, C. Okay, what is class A? For class A, the percentage predicted percentage dissatisfied should be less than 6. Okay, if it has to be less than 6, then the PMV value has to be between -0.2 to +0.2. This means that if a person is wearing 1 kilo clothes and 1.2 meter activity, then the temperature has to be between 21 to 22 in winter and 23.5 to 25.5 in summer. Similarly, for class B, class C, etc., the different conditions are given. Okay. So ISO divides the buildings into 3 different classes, and the conditions specified for these different classes are different. Okay. And again, studies show that the comfort temperature can be increased or decreased depending upon the activity or clothing level. Okay, you can increase the temperature by increasing the air velocity. You have to decrease the temperature if a person is doing more activity or wearing more clothing, etc. And generally, studies shows that relative humidity is not so important as long as you are keeping the temperature within the range. So you can maintain the relative humidity between 30% to 70%. Okay, and generally most of these standards specify that the air velocity should be between 0.1 meter per second to 0.8 meter per second. Okay. Then comes the ISHRAE thermal comfort standard. ISHRAE thermal comfort standard is very popular standard, and it is applicable to healthy adults for indoor spaces with activity levels less than 2 meters. And it is for atmospheric pressure up to an equivalent altitude of 2000 meters. You cannot apply it to a place which is, let us say, 4000 meters from the sea level. Okay. And it is also valid for spaces where human beings have spent more than 15 minutes. Okay. It is not valid where they spend only few minutes. Okay. And they have given different means for use of these standards. For example, this standard, you can use a graphical method of this standard if these conditions are satisfied. You can use a mathematical model and a program if these are the conditions. Okay. And if the air velocity is more than the specified, then there is a third correction. Okay. So this is roughly your ASHRAE standard. This very important chart, which is called as an ASHRAE thermal comfort chart. Okay, you can see that ASHRAE thermal comfort chart, the conditions are given for which this chart is valid, and you can see that there is a hatched area. Okay, this area is your comfort zone, and you can see it resembles a psychrometric chart with the humidity ratio on the y-axis and the temperature on the x-axis. But this temperature is not the dry bulb temperature; it is the operative temperature. Okay, and if a thermal environment falls within this shaded area, then that environment will be comfortable. Okay, so if you know the environmental conditions, and if you put that environmental conditions on this chart, and if you find that it is inside the shaded area, then environment is supposed to be comfortable. Okay, so this is the ASHRAE thermal comfort chart, which is very widely used. And as I said, they have also given an adjustment. The actual thermal comfort chart given earlier is valid for low velocity. The velocity is high, then we can make this adjustment. Okay, you can see that for different velocities. Okay, what are the comfort temperatures? Right, comfort operating temperatures for different clothing. Okay, it is very important to note this chart very carefully. You can see that if you are willing to go for higher velocity, your comfort temperature can be as high as 31 degrees. Okay, if you are wearing 0.5 clothes and the met rate is 1.2, then the temperature can be as high as 31 degrees centigrade if you are allowing air velocity of 1.6. Okay, so this is the adjustment for higher air velocity. Okay, so this is actually a thermal comfort chart. Actually, thermal comfort chart also says that apart from maintaining the neutral conditions, etc., you also have to take care of certain other conditions like the radiant temperature asymmetry has to be within this range. That means you cannot have very cold floor or very hot floor or very hot ceiling or cold ceiling, etc. So these are the additional conditions which have to be satisfied along with the charts. Okay. Finally, this is your European standard. Again, just like ISO standard, the European standard divides the building into 3 different classes. So they have class 1, 2, 3. And the description of the classes are given here. You have class 1 means you have very high level of expectation, and that is applied for these conditions. And if you are maintaining, providing a class 1 thermal comfort, then your PM should be within plus or minus 0.2. And the temperature limitation cannot vary by more than 2 degrees. Similarly, class 2 is slightly more relaxed, and the PMB is plus or minus 0.5 and temperature plus or minus 0.2. Right? Finally, you have class 3, which is acceptable. So higher range of PMB is acceptable, and the higher range of temperature limitation is acceptable. Okay, so these are all the standards which are for air conditioned buildings. For non-air conditioned buildings also we have standards. For example, non-air conditioned buildings based on the adaptive thermal comfort, you have ISHRAE standard. You also have a European standard, right? You can see that in this standard is a very simple standard. Here, this is the comfort temperature. This comfort temperature is expressed as a function of the some mean outside temperature. So if you know the outside temperature, using this simple equation, you can calculate at what temperature people are likely to be comfortable. You don't require other information like clothing, air velocity, humidity, etc. Right? So this is the ISHRAE standard, and this is your European standard. You can see that more or less they are almost similar, and these standards are applicable for these ranges. Okay. So I've already explained here P out is some sort of a average outside temperature, and PU is the comfort temperature. And generally, these standards are valid for low metabolic rate. They're not valid for very high activity levels, etc. And the most important thing is when you are applying these standards, there has to be provisions for adaptations, right? Because you remember that adaptive thermal comfort standards work. You are allowing the people to adapt. If you say that the people cannot change their clothing, or they cannot open or close windows, or they cannot increase or reduce the air speed, etc., then these standards are not applicable. Okay, so that is something you have to keep in mind. Adaptive thermal comfort standards means you must allow people to adapt. Okay. And these temperatures can be varied if you are willing to accept slightly higher amount of dissatisfaction. For example, you can see this is the ISHRAE adaptive the thermal comfort standard for naturally ventilated buildings. Just like your ISHRAE comfort chart for air conditioned buildings, you can see that here you have the mean outside temperature, and here you have the comfort temperature. You can see that the comfort temperature increases as the mean outside temperature increases. And you can see that again, if you are maintaining within this range, then you are willing to accept 10% dissatisfaction. If you are willing to accept it over a larger range, then you are willing to accept 20% dissatisfaction. Okay. So this standard is meant for buildings which do not have air conditioning, but which have adaptive means. Okay. And again, from this building, you can see that the comfort temperature can vary from about 17 degrees to as high as about 31 degrees. So please don't keep the thing in your mind that only 24 degrees or 25 degrees means comfort. If you are willing to the adaptation, then people can be comfortable at temperatures as high as 30 degrees or so. Okay. One very important thing when you are applying standards are, especially when you are applying the standards for air conditioned building, you have to measure a lot of things. So all the standards specify what are the things to be measured and what are the range with which the instrument should be able to measure and what is the accuracy of the measurements. Okay, these are very important. Finally, whether it works or not depends upon the accuracy of the instruments and the method used and with what rigor people are measuring these things. Okay, and all standards clearly specify what to measure, what are the things that one has to measure, not only what to measure, where to measure. For example, when we say air temperature, where do we keep the sensor? Should it be closer to the floor, closer to the ceiling, should it be the midway, right? So these things are specified in all standards. Where are the locations where we have to keep all these sensors? Okay, so what to measure, where to measure, okay, and then when to measure. When to measure means that you have just switched on the system, right? Should we measure immediately or for how long we have to measure, right? And finally, how to measure. Okay. So whenever you are using these standards, the standards are pretty voluminous documents. They give a lot of details about all these things, right? So when you are applying standards, it is not just that one value or anything. You have to take care of all these aspects. Only then the standard makes sense, and whatever you are reporting makes sense. Okay. So this is briefly about human thermal comfort and the thermal comfort standards. You have to understand that air conditioning is a product, and when you are buying a product, you must make sure that the product is meeting the standards, right? Or similarly, when you are selling a product, you have to ensure that it is standards. So one should be aware of these standards. Only then we'll be able to know whether what we are buying or what we are selling finally meets the purpose or not. Okay, so that is why it is important to understand these aspects. Okay, so finally, I'll just conclude. Currently, the standards are available only for air conditioned buildings and non-air conditioned buildings. We really don't have a standard for what is called as a mixed mode building. Mode building means it can be used as a air conditioning or a non-air conditioning, right? So people are trying to develop standards for mixed mode building also. Okay, as I mentioned in the beginning, the problem with air conditioning is may provide comfort, but it also consumes a lot of energy, right? And as you know, the energy prices are increasing continuously, and because of the global warming, all cities are becoming warm. So we require air conditioning. At the same time, we also have energy problem. So people feel that the thermal comfort should also consider the energy consumption aspects. And several studies show that one very important aspect which is missing in these standards is the personal control. That means studies show that if you allow a person to control his local temperature or the air velocity around him, then we can achieve a better satisfaction with minimum energy consumption, right? So the latest research is on different types of personal control systems. So the purpose of the personal control systems is to provide thermal comfort to a larger percentage of people with less amount of energy consumption. Okay, so this is a very interesting thing. So in view of all these aspects, it is expected that the standards evolve continuously. It's not that standards are static. Every year they revise the standards. So when you are referring to the standard, they clearly specify in which year the standard is brought out, okay, and its validity, etc. Okay, so it is expected that in coming years we'll see more and more revisions of the standards in such a way that finally we'll be able to keep ourselves comfortable without wasting too much of energy. Okay. So that is all I have. So these are some of the important literature which I have used for my presentation. Literature is very rich on thermal comfort and standards. Okay, thank you for your attention. If you have any questions, you are most welcome. I think I have taken more time than allowed. Thank you.
No, sir, not any problem. We are having a lot of time now. Question the participant can ask. Whereas still now we are having some of the questions already received. Shall I convey it to you, sir?
Shall I stop sharing or is it okay?
It's okay, sir. Not an issue. If the presentation is over, I mean, from your side,
okay.
Shall I ask the question, sir?
Yeah, sure.
There is a question from Mr. Sudesh Pawar. Which is the latest human thermal? Which one is the latest human thermal model?
Human thermal model. Actually, as I mentioned, the latest model divide the human being into infinite nodes, right? So previously, they started with 2-node model, then they went to 25-node model, then 63-node model, 250-node model. Now they say that you can have any amount of nodes. Okay, why it is possible is nowadays people are using numerical software, computer software for solving. Okay, the moment you're using software, sophisticated software, you can divide human being into any amount of parts. Okay. So the latest software which are based on computational fluid dynamics, etc., have infinitely many nodes. Okay. So they are the latest thermal models.
Wonderful.
Have I answered the question?
Yes, two more questions. Actually, these two questions are from my side. My own question, right? First question from my side is: does the metabolic rate of the human body depends upon the psychological factors which are going on under the mind of a human being? Say maybe in fear, or say happiness, or say afraid of certain thing. In that case, the sweat immediately starts to come out. So, does it mean that the metabolic rate of human body depends on the psychological factors?
Metabolic rate mainly depends on the physical activities.
Not on the psychological factors.
Psychological aspects are not supposed to have any strong effect, but if the psychological aspects lead to altered physical activities, then the metabolic rate gets affected.
So in that case, there is a small counter question, sir. In that case, then let's say one example, like a human body is sitting in a cabin and someone tell him like there is a worm under your chair. So immediately the sweat will start to come out. So what does it mean? Does it mean the sweat is coming out? The body is emitting out the sweat. So don't you think that there is a somewhat metabolic rate change in the metabolic rate of human body?
Let me give an example. Let us say that two people are sitting in chair, right?
Okay.
Okay. and both are relaxed, etc. So then it is expected that both of them will be generating the same amount of steam. Okay, but let us say that one person for some reason is under some mental stress.
Right.
Okay, mental stress may trigger some other thermoregulatory mechanism because of which he may be sweating, right?
Okay.
So that, but this he's sweating doesn't mean that he's generating more heat.
Okay.
So these are all the byproducts of this thing. But if you consider just as the amount of heat that is being generated, that is mainly depending upon the activity. That means that two people sitting will generate same amount of heat. Okay.
One more question, sir. Whatever from human comfort, thermal comfort perspective, what is the measure of degree of hotness or degree of coldness felt by the human body? Is it the temperature difference between the human body and the surrounding, or is it the rate of heat transfer that is taking place between the human body and surrounding? This is what the degree of hotness or coldness felt by the human body, not by the thermometer.
So you can see that obviously, if you consider the models on which all these standards are based, the models are based on PMV. PMV is nothing but the thermal sensation, right? So thermal sensation means the person is feeling cool or whether he is feeling warm, etc. So feeling of cool or warmth depends upon how much heat he is transferring.
Okay, so that it means the answer is it is the measure of rate of heat transfer, right?
Obviously.
Okay.
And you have to understand that the heat transfer depends upon the temperature. Okay, among other factors. Temperature is one factor, there are other factors.
Okay. Fine, sir. There is one more question from Professor Prashant Patonkar. Please elaborate on the difference in the design of suits for the astronauts, firefighting person, and a soldier working in the cold region from the thermal point of view.
Well, I'm not an expert in this thing, but as you know, for example, if you consider a soldier working in Ladakh or Leh, where the outside temperature is minus 40 years old, right? So then he'll be losing much more heat than what he's generating, right? So you have to reduce the heat transfer rate from the body to the surroundings. That means the suit that you are providing should have very good insulating value, right? Should have highly insulated. This is common knowledge. We know that we wear sweaters in winter because sweaters have better insulating values, right? But there are finer aspects. For example, if you consider an astronomical suit, it also has other functions apart from thermal comfort. Thermal comfort is one of the aspects. There are many other aspects which are taken into account. For example, he is releasing sweat. How the sweat leaves the body, right? It is not just only thermal insulation. Okay. So these astronomer suits or the soldier suits, etc., also to consider other factors apart from thermal comfort. Thermal comfort is a very important factor, but in addition to thermal comfort, the other factors also have to be taken into account. Many other functions. I hope I have answered.
Yes, thanks. Fine, sir. The questions are over. And any more point would you like to add? You can.
Okay, then are we closing?
Okay, sir. At last, at the end, I would like to tell you that we are really fortunate enough that you have made yourself available here on this platform.
But tell me how much time I have taken?
About an hour. And we have closed that. Fine.
Okay, right. Thank you so much and best of luck.
Thank you, sir. Thank you so much, sir. Thank you.
Every success has its own story. And in case of PCCOER, short for Pimpri Chinchwad College of Engineering and Research, the story began from its very inception in the year 2014. We are creating this success story under the aegis of Pimpri Chinchwad Education Trust, PCET, which was established by late Shri S.B. Patil in the year 1990. The trust has the vision to provide value-added education to the society in multiple dimensions, right from nursery up to doctoral program in all professional streams. PCET is a well-established
today's second session has been postponed by about 15 minutes. So let us just okay.
Every success has its own story. And in case of PCCOER, short for Pimpri Chinchwad College of Engineering and Research, the story began from its very inception in the year 2014. We are creating this success story under the aegis of Pimpri Chinchwad Education Trust, PCET, which was established by late Shri S.B. Patil in the year 1990. The trust has the vision to provide value-added education to the society in multiple dimensions, right from nursery up to doctoral program in all professional streams. PCET is a well-established and time-tested brand in education. PCET governs 9 institutes, which include a public school, a polytechnic, a management institute, an architecture college, a science and commerce college, and 4 engineering colleges.
Pimpri Chinchwad College of Engineering and Research is one of the leading colleges of Pune University. We follow the simple principle of 5-pillar philosophy. In this 5-pillar philosophy, the academic excellence is the first and the important pillar. The second one is research and innovation. Third is the training and development aspect. Fourth is the social awareness angle, and fifth is ethics and values. As a result of this, the students are developed in all dimensions, and the college is emerging very fast among the top colleges of Pune University as well as at the state level.
PCCOER has been founded by highly qualified and proficient academicians. We are located in the most refined cluster of innovative firms at the heart of an industrial hub. Here, our students have numerous career opportunities. PCCOER runs UG courses for civil engineering, computer engineering, electronics and communication engineering, and mechanical engineering. These courses have been approved by AICTE, DT, and Government of Maharashtra. The institute is affiliated to Savitribai Phule, Pune University. PCCOER is a place of excellence where your vision comes true. At PCCOER, you can wander through the ocean of knowledge and build the courage to seize your aspirations. We merge technology and participative learning to make your education more engaging, more gratifying. PCCOER has a skilled team of experienced, highly qualified, dedicated faculties and associates. They play their crucial role in fulfilling the vision of PCCOER. We have a systematic and standardized pattern for work execution and a perfect teamwork. We have a comfortable, pleasant, healthy and friendly campus where the students can exploit their true potential. We provide a self-sufficient and sustainable environment to develop the perception of how various concepts fit in collectively. Our approach has always been student-centric, and we stay attentive to their demands. The institute building is not just a structure of bricks and mortar, it's a temple for the learners. We provide the best teaching learning processes and a research provoking ambience. We have well-equipped laboratories with state-of-the-art instruments that ensure that you are at the cutting edge of engineering and technology. Our infrastructure includes all the necessary suite of tools and software which help the students bloom.
We organize guest lectures of expert speakers from industry and reputed institutions like IITs for students as well as for faculties. We organize site visits, industrial visits in each and every subject for the students so that students are exposed to the three-dimensional engineering realities. It is also mandatory for the students to undergo internship so as to gain invaluable hands-on experience. We have smart boards, we have screens, projectors, computers in each and every classroom. We have state-of-art laboratories where we encourage the student to perform experiments, to perform tests, to develop projects, to develop working models.
The institute campus is rich with greenery and blooming flowers which lend a soothing touch to the demanding academic tasks. We have a huge ground where students enjoy outdoor sports and an open gymnasium for the fitness freaks. The indoor gymnasium has facilities for many indoor games. We have a vast library that houses more than 2,000 titles and 10,000 volumes of technical books, subscription to several technical journals, e-journals, and a large collection of literary books to cater every intellectual need. The reading hall has the ambience that motivates the students to stay focused and excel confidently. Empty stomach results in empty mind. Hence, we have excellent arrangements in the form of canteen and mess to satisfy the physical appetite of the students and staff. Other facilities on campus include covered parking, CCTVs, 24/7 security, and firefighting system. We have our own comfortably furnished hostel accommodation for boys and girls. Intellectual and psychological growth of the students is the centerpiece of PCCOER. Our students excel not only in academics but also in cultural and social events. We create various mind-feeding activities and conduct several exercises such as yoga workshop, mind education, wall magazine, self-awareness programs, inspirational programs, project-based learning, and annual gatherings. Our students participate and shine in co-curricular and extracurricular activities like Baha, Go-Kart, Robocon, Tiffin, Purushottam Karandak, Firodia Karandak, Daji Kaka Gadgil Karandak, and many more. Socio-economic empowerment of society is everyone's responsibility. PCCOER has always been a torch bearer in shouldering such responsibilities.
The students of our NSS unit regularly arrange blood donation camps. This year, our blood donation camp saw a response of about 150 blood donors. Our students regularly visit old age homes and orphanages where they feel very happy and joyous to spend time with underprivileged elderlies and children. Students regularly take part in social activities like tree plantations regarding environment, as well as various cleanliness drives as part of the Swachh Bharat Abhiyan. Part of Unnat Bharat Abhiyan for rural development by the Government of India, Our college has adopted 5 villages in Mawal Taluka of Pune district.
We are equipping our students with the set of skills, capabilities, and attitudes they need to succeed as employees, leaders, and entrepreneurs in modern world.
We are probably the only institute in India which has placed its 77% of students in first 2 batches. Around 400 plus companies give opportunity of placements to our students every year. We train our students right from second year, considering their improvement for soft skills, aptitude skills, technical skills. So recently we have conducted drive of Amazon where the maximum package given was around 28 lakhs. 2 of our students got selected in Japan for the packages of around 20 lakhs and 17 lakhs.
I'm currently working in a Japanese company, tech firm, which is located in Tokyo, and I got a package of 17 lakh. When I was in second year, the Japanese training started in our college, and our HOD was very supportive, and she was like, you should do this training because it will be beneficial in your future.
Our central placement cell has placed more than 20,000 students. We have conducted 125 off-campus drives for 33,000 students from all over Maharashtra. Here, more than 1,400 students have secured their dream job. We have also channeled 150 online recruitment examinations. We are a vibrant alliance of educators and scholars who guide and motivate the students by setting an example, not by empty words. We at PCCOER emphasize on breakthrough engineering with breakthrough results.
माझा मुलगा शिवम भावसार हा याने डिप्लोमा केलेला आहे इन मेकॅनिकल इंजिनिअरिंग. तर त्याच्यासाठी आम्हाला डिग्रीसाठी खूप चांगलं कॉलेज आम्ही शोधत होतो. त्याचं सगळं व्यक्तिमत्व फुलेल, ऑलराऊंडर बनेल याच्यासाठी आम्ही बऱ्याच कॉलेजचा शोध घेतला. त्याच्यामध्ये नाशिकमध्ये आम्हाला असं कळालं की पिंपरी चिंचवड कॉलेज ऑफ इंजिनिअरिंग अँड रिसर्च हे कॉलेज खूप चांगलं आहे. आम्ही पुण्यातले 3-4 कॉलेजमध्ये गेलो, तिथे रिसर्च केला आणि त्याच्यानंतर निर्णय घेतला की आमच्या मुलासाठी हे कॉलेज योग्य आहे.
So I decided to get my admission in this particular college, that is Pimpri College of Engineering and Research, for my daughter Pallavi in civil engineering. She is doing really great in academics. Not only in academics, but there are various activities like curricular activities, co-curricular activities, extracurricular activities, and even mini projects. I am really satisfied that I took a very correct and very right decision by putting my daughter in this particular college.
No doubt our college is excelling in the placements part as well as the educational part, but today I would like to put forth one more perspective, that is the higher education. I would like to mention that I'll be pursuing my Masters of Science, MS in Computer Science from University of Southern California, Los Angeles next year. I would like to mention that all my teachers, my head of the department, our principal, our Dean III of Training and Placement Cell, everyone supported me and encouraged me. Definitely, I will say that with the help of this college, I have personally developed a lot.
With the combined, sincere and focused efforts of management, staff and students, PCCOER has established a world record of filing highest number of copyrights by any organization in a single day. And this grand achievement was recognized and honored by World Records India and India Book of Records. Our faculties and students have published more than 280 research papers in international and national journals of highest standing in the current academic year. PCCOER has bagged many awards, amongst which are Innovative Leader National Award, IARDO Award for Academic Leadership, Special Award for Patents and Copyrights Filing, Global Education Excellence Award for the most result-oriented engineering college, and outstanding upcoming engineering college in Maharashtra.
The research and development is a very important pillar for the progress of any institute. Not only filing of patents and copyrights, we have 8 products in a market. In order to strengthen the research and development according to the industry, we have more than 20 MOUs. All these MOUs are active MOUs. Under that, each department having an industrial visit, then internship for the students, guest lectures, workshops, seminars. So these seminars and all these activities try to bridge the gap between industry and academy.
Now all this is reflected in our university results. We have started just 5 years back, and in this very short span, we have achieved a position amongst top 5 best institutes in Pune University. Now for an institute in its infancy, this is a great achievement.
We at PCCOER help the students to change the world for the better through their education. We create not only brilliant professionals but also responsible citizens. Our management, faculty, staff and students have a single motto: to become a national pride. It is the very secret of our rapid growth. There is a difference between dreaming and realizing dreams. Dreams require effortless sleep, and realization requires sleepless efforts. Everything is possible for those with a vision, a plan of action, and a determination to make it happen. Be a part of PCCOER to fulfill your dreams.